For generations, humanity imagined interstellar travel as a problem of speed. Build a faster engine, discover a more powerful fuel, push a spacecraft closer to the speed of light. The assumption seemed obvious. The stars were distant, but distance was merely an engineering challenge waiting for a solution. Yet buried beneath that assumption was a far stranger possibility. What if humanity never solved the speed problem at all? What if the first successful journey to another star was not completed by astronauts crossing decades of space? What if it was completed by entire civilizations crossing centuries? This is where the story of the generation ship begins. Not as a machine, not as a spacecraft, but as a question so large that it blurs the boundary between engineering, biology, sociology, history, and philosophy. How long could a generation ship survive in deep space? At first glance, the answer seems straightforward. Build a giant vessel, fill it with food production systems, create living quarters, provide energy, protect it from radiation, then let it travel. Simple. Except nothing about this idea is simple, because the moment a generation ship leaves Earth, something unprecedented happens. The mission stops being a voyage. It becomes a world, and worlds obey different rules than spacecraft. A normal mission has a beginning and an end. Astronauts launch. Astronauts arrive. Astronauts return. A generation ship breaks that pattern entirely. The people who board the vessel at launch are not the people who reach the destination. Their children might not reach it either. Neither might their grandchildren. Entire lifetimes could pass within its walls. Entire histories could unfold. Entire civilizations could rise and fall, all while the ship drifts through silent darkness between stars. This idea sounds futuristic, yet strangely, it is also ancient. For most of human history, journeys consumed entire lifetimes. A merchant leaving one side of the world often never returned. Settlers crossed oceans knowing they would never again see the lands of their birth. The generation ship extends that logic into the cosmos. Except the ocean is no longer water. It is space itself, and space is far less forgiving. Imagine a vessel heading toward a star system 10 light years away. Suppose it travels at 1% the speed of light. That sounds fast. In reality, it would require roughly 1,000 years to arrive. 1,000 years. The distance between modern civilization and the early Middle Ages. When the ship launches, people still remember Earth when it arrives. Earth itself may have changed beyond recognition. Languages could evolve. Nations could disappear. Entire cultures could emerge and vanish. The passengers would not merely be traveling through space. They would be traveling through history. But a deeper mystery was already lurking beneath the numbers, because reaching another star may not be the hardest part. Surviving the journey might be. At first, engineers approach the challenge like any other technical problem. How much food is required? How much water? How much energy? How much living space? The calculations seemed manageable. A sufficiently large vessel could theoretically recycle resources indefinitely. Water could be purified. Air could be regenerated. Waste could become fertilizer. Plants could provide oxygen. Everything could remain within a closed loop. The ship would become a tiny artificial Earth, a self-contained island floating through interstellar darkness. Problem solved. Or so it appeared. Then researchers began studying actual closed ecosystems, and what they discovered was deeply unsettling, even on Earth. Maintaining stable environments proved extraordinarily difficult. Tiny imbalances accumulated. Unexpected feedback loops emerged. Species populations fluctuated. Chemical cycles drifted. Systems that appeared stable gradually became unstable. A closed ecosystem was less like a machine and more like a living organism. Difficult to predict. Difficult to control, sometimes difficult even to understand. This raised an uncomfortable question. If maintaining a self-sustaining environment is challenging on Earth, what happens when that environment must survive for centuries without external support? The answer was not obvious, and the deeper scientists looked, the stranger the problem became. Because a generation ship does not simply carry life, it contains life. Every insect, every microbe, every plant, Every human, every ecological relationship, every invisible biological process, all trapped inside a finite volume. Imagine placing an entire civilization inside a bottle. Now seal the bottle. Then ask it to survive for 1,000 years. Suddenly, the challenge feels very different. The ship is no longer transportation. It is an ecosystem, a society, a biosphere, perhaps even a new branch of human history. Yet another mystery waited beneath this one. Even if the ecosystem survived, would the people? Most discussions about space exploration focus on physical dangers, radiation, vacuum, equipment failures, but generation ships introduce an entirely different threat: time. Time changes everything. Cultures evolve, beliefs transform, memories fade, knowledge disappears. The passengers who launch the vessel understand its purpose. The descendants born centuries later may not. Consider a child born on board after 500 years. Earth would be a story. The destination star would be a story. The mission itself might feel like mythology. Their reality would be the ship, the corridors, the farms, the machinery, the artificial sky, the closed horizon, the walls. Why should they care about promises made by distant ancestors long dead? This question may sound hypothetical, yet history offers countless examples. Societies rarely preserve beliefs unchanged across centuries. Religions evolve. Languages shift. Traditions mutate. Narratives fracture. Even written records can become misunderstood. What happens when those forces unfold inside a vessel isolated from the rest of humanity? No one truly knows. And that uncertainty reveals something important. The greatest challenge facing a generation ship may not be technical. It may be cultural. A spacecraft can be repaired. A civilization is harder to maintain. The distinction seems subtle, but it changes everything, because suddenly the mission is no longer asking whether humans can build a vessel capable of crossing interstellar space. The mission is asking whether humans can preserve a society across timescales longer than recorded history. That is a much larger mystery, and it forces us to confront a hidden assumption. We often imagine humanity as a stable entity moving through time, but history tells a different story. Human societies transform constantly, sometimes gradually, sometimes violently. The people who launch a generation ship may have goals entirely different from the descendants who inherit it. And if those descendants abandon the mission, what happens then? The question seems distant, yet it would eventually become one of the most serious concerns in generation ship research. Because before scientists could determine how long a ship might survive, they first needed to answer something even more fundamental. Could a human civilization remain stable while trapped inside an artificial world for centuries? The answer seemed obvious. It wasn't. And the first clues would emerge from an unexpected place much closer to home, long before humanity ever built a generation ship. A strange experiment unfolded on Earth. It began with optimism, the belief that science had finally learned enough about life to recreate an entire ecosystem from scratch. If a self-contained world could survive on Earth, perhaps one day it could survive among the stars. The project became known as Biosphere 2. Its name carried a quiet implication. Earth itself was Biosphere 1. This new structure would become humanity's second attempt. At first glance, it looked almost magical, a sealed environment covering more than 3 acres, rainforests, deserts, agricultural fields, artificial oceans, thousands of species, 8 human inhabitants, everything carefully designed to function without outside support. For 2 years, the residents would live completely enclosed. No external air, no external water, no external food. A miniature world beneath glass. To many observers, it seemed like a glimpse of humanity's future. Perhaps this was what life aboard a generation ship would resemble, a carefully balanced ecosystem sustaining people indefinitely. Yet hidden beneath the excitement was a question nobody could answer with certainty. Could a complex ecosystem actually remain stable once sealed? The answer arrived faster than expected, and it was unsettling. At first, everything appeared normal. Plants grew. Animals survived. Food was produced. The residents adapted. The system seemed to function. Then, small anomalies began appearing. Nothing dramatic, nothing catastrophic, just tiny irregularities. But ecosystems are sensitive things. A slight imbalance today can become a major problem tomorrow. One of the first warning signs involved oxygen. Inside the sealed environment, oxygen levels slowly began falling. No one expected it. The biosphere was designed specifically to recycle air, yet the decline continued, month after month. Eventually, oxygen concentrations dropped to levels comparable to standing atop a mountain thousands of meters high. Residents became exhausted. Concentrations suffered. Simple tasks grew difficult. The ecosystem was behaving in ways scientists had not predicted. The mystery deepened. Where was the oxygen going? Had the plants stopped producing enough? Were microorganisms consuming more than expected? Had some hidden chemical process emerged? Investigators eventually uncovered part of the answer. Concrete within the structure absorbed oxygen through chemical reactions. Tiny interactions between materials and atmosphere were altering the entire system. No one had fully anticipated the effect. A reminder that even carefully designed environments can harbor hidden behaviors. And that discovery carried profound implications, because a generation ship would contain vastly more complexity, more materials, more biological interactions, more unknown variables. If a sealed ecosystem struggled after a few years on Earth, what might happen after centuries in deep space? The question lingered, and oxygen was only the beginning. As researchers examined Biosphere 2 more closely, other surprises emerged. Many species died out, others multiplied unexpectedly. Insects became dominant in places where they were not supposed to dominate. Pollinating species disappeared. Ecological relationships shifted. The system evolved along pathways its designers never intended. This revealed a deeper truth. Ecosystems are not machines. Machines perform predictable functions. Ecosystems adapt. They mutate. They respond to pressures in ways that can be difficult to forecast. Trying to control one is like trying to choreograph every wave in an ocean. Possible for a moment, impossible forever. This realization forced scientists to reconsider a basic assumption. Perhaps a generation ship could not be engineered like a spacecraft. Perhaps it would need to be treated like a living world. And living worlds rarely remain static. A new mystery emerged. If ecosystems inevitably change, what happens to a ship that must survive not for years, but for centuries? Imagine a forest inside a generation ship. The first generation plants it. The second generation maintains it. The fifth generation modifies it. The 20th generation may inherit something entirely different. Species composition changes. Microbial communities evolve. Environmental conditions drift. The ecosystem becomes a moving target, like a river whose shape changes while you attempt to map it. This posed a troubling problem. The ship's life support system might not fail dramatically. It might simply transform slowly, quietly, generation after generation, until one day the environment supporting human life no longer behaves as expected. The danger would not announce itself with explosions. It would arrive as accumulation, tiny changes layered upon tiny changes, a silent drift. And history suggests such drifts are surprisingly difficult to recognize from within. People living through gradual change often perceive stability. Only later do historians identify transformation. The same might occur aboard a generation ship. Its inhabitants may believe their world is functioning normally. Meanwhile, invisible processes slowly reshape the foundation of survival itself. This led researchers toward an even more unsettling realization. The most dangerous threats may not be external. When people imagine interstellar voyages, they usually picture dramatic hazards, radiation storms, asteroid impacts, mechanical failures. These dangers are real. Yet many experts increasingly suspected something else. The greatest threats could emerge from inside the ship. Biological drift, ecological instability, cultural evolution, knowledge loss, psychological adaptation, not enemies attacking from outside, processes unfolding from within, like roots slowly cracking stone. The analogy is important. A fortress can defend itself against invaders. It struggles to defend itself against time. And a generation ship is ultimately a fortress built against time itself. The more scientists investigated closed ecosystems, the clearer the challenge became. Survival is not merely about maintaining resources, it is about maintaining relationships. Relationships between species, relationships between technologies, relationships between generations. Break enough of those connections, and the system begins to unravel. Yet there was another mystery hidden even deeper. Because even if ecosystems remained stable, and even if technology endured, human beings themselves presented a problem no engineer could solve. The issue was surprisingly simple. How many people are enough? At first, the answer seemed obvious. Take a few hundred volunteers, provide living space, allow families to grow. The population continues. The mission survives. Case closed. Except biology is rarely that straightforward. A small population faces invisible risks, genetic bottlenecks, inherited disorders, reduced diversity, random fluctuations. Over long periods, these effects accumulate. And unlike oxygen levels or mechanical failures, they can remain hidden for generations before revealing their consequences. Scientists began running simulations. What they found would transform the entire discussion. Many proposed generation ships simply did not contain enough people. Their populations would gradually become vulnerable to genetic instability. The problem was not immediate. That made it more dangerous. Because the effects emerged slowly. Decades, centuries, sometimes longer, like a crack spreading through a foundation, invisible until it becomes impossible to ignore. Suddenly the question was no longer how to build a ship. It was how to preserve a population. And preserving a population across centuries turned out to be far more difficult than preserving a machine. The deeper researchers looked, the more troubling the numbers became. Because surviving the journey might require far more people than anyone originally imagined. And that revelation would force scientists to confront one of the most fundamental mysteries in the entire generation ship concept. How small can humanity become before it stops being sustainable? The answer would challenge nearly every early vision of interstellar travel, and the implications reached far beyond the ship itself. At first, the numbers looked reassuring. A few hundred people seemed like a large community, large enough to support families, large enough to create institutions, large enough to sustain a culture. After all, many human settlements throughout history began with far fewer. Entire colonies were founded by only dozens of individuals. Remote islands were populated by surprisingly small groups. Why should a generation ship be any different? The assumption felt reasonable. Then genetics entered the investigation, and the mystery suddenly became much larger. Because populations do not survive simply by existing. They survive by maintaining diversity. Hidden within every human being is an immense library of genetic information. Millions of variations, millions of possibilities. A reservoir of resilience accumulated across countless generations. The larger a population, the larger that reservoir tends to be. The smaller a population becomes, the more vulnerable it grows. Not immediately, not dramatically, but gradually. Like a deck of cards losing pieces one at a time. The game still works at first, then eventually something important is missing. Scientists studying isolated populations on Earth had seen this pattern before. Small groups often faced unexpected genetic challenges. Certain inherited conditions became more common. Rare traits became widespread. Overall adaptability declined. Chance itself became a powerful force. This phenomenon is known as genetic drift. The term sounds harmless, almost gentle. Yet its consequences can be profound. Imagine copying a book, then copying the copy, then copying the copy of the copy, again and again. Tiny errors appear. Most seem insignificant. Over time, they accumulate. The text slowly changes. A population functions in a similar way. Each generation passes information forward. Each generation introduces variation. Over centuries, small populations can drift in unexpected directions, and a generation ship may be one of the most isolated populations humanity has ever created. No immigration, no new genetic input, no external replenishment, only descendants inheriting the legacy of those who launched the mission. This raised an obvious question. How many people would actually be required? The answer proved surprisingly elusive. Some early estimates suggested hundreds, others argued for thousands. More conservative studies proposed tens of thousands. The range itself revealed how little certainty existed, because the challenge was not merely biological, it was statistical, and statistics become increasingly strange across long timescales. A population of 500 might survive 1 century. Would it survive 5? Would it survive 10? The uncertainty widened dramatically as the timeline expanded. What appeared safe over decades could become risky over millennia. And this is where the generation ship began revealing its true nature. It was not simply a spacecraft crossing distance. It was an experiment in time. The farther the journey extended, the more time became the dominant variable. Time affects ecosystems. Time affects technology. Time affects culture. And time affects genetics. A generation ship must survive all 4 simultaneously. That realization led researchers toward a disturbing possibility. Perhaps the minimum population required for survival was far larger than anyone wanted to admit. Imagine constructing a vessel capable of housing 10,000 people. The engineering challenge becomes enormous. Food production scales upward. Living space expands. Energy requirements increase. Waste management grows more complex. Every solution creates additional problems. The ship begins resembling a city rather than a spacecraft, and cities possess dynamics of their own. This was the first major complication. Increasing population improves genetic stability, but increasing population also increases social complexity. The two goals pull in opposite directions. A smaller population is easier to support. A larger population is easier to sustain genetically. Which risk is greater? No one knew. The mystery deepened. History offered clues, but not answers. Human societies have repeatedly experienced demographic bottlenecks, wars, famines, epidemics, natural disasters, entire populations reduced to fractions of their former size. Yet those societies usually remained connected to larger human networks. Trade continued. Migration occurred. New people arrived. The isolation of a generation ship would be unprecedented. Its inhabitants could not simply leave. They could not recruit newcomers. They could not seek help. The ship would carry everything it needed from the moment it launched, a sealed branch of humanity drifting alone between stars. The more scientists modeled such scenarios, the more unexpected complications emerged. For example, what happens if a disease spreads through the population? Earth civilizations possess billions of people. Local outbreaks rarely threaten the entire species. A generation ship is different. Its population might number only thousands, perhaps fewer. A single epidemic could alter the mission permanently. Not necessarily through fatalities alone. It could disrupt institutions, reduce expertise, damage social stability, create cultural trauma lasting generations. The same logic applies to accidents, political upheaval, resource shortages, unexpected environmental changes. Every disruption affects a much smaller and more vulnerable population. This realization introduced a new analogy. Generation ship is less like a nation. It is more like a lifeboat, a very large lifeboat, a technologically sophisticated lifeboat, but still a lifeboat. Everything matters. Every loss carries consequences. Every imbalance echoes through the system. And because the population remains finite, recovery becomes increasingly difficult. Yet just as the genetic mystery seemed to dominate the discussion, another discovery complicated everything. It appeared scientists had finally identified the primary threat. Then the answer created a bigger question. One of the recurring lessons of generation ship research is that solutions often generate new problems. A larger population improves genetic diversity, but larger populations require governance, conflict resolution, economic systems, education systems, cultural institutions, rules, laws, power structures. Suddenly, the challenge expands beyond biology. Now, political science enters the story, because people do not simply survive together, they organize, they compete, they cooperate, they disagree, sometimes peacefully, sometimes not. History offers countless examples of stable societies collapsing unexpectedly. Empires fracture, governments fail, institutions decay, social trust erodes. The causes vary. The outcome remains familiar. Complex systems become unstable. Could the same happen aboard a generation ship? The possibility was difficult to ignore. Imagine a political crisis emerging after 300 years. The original mission planners are long dead. The founding generation exists only in records. Perhaps those records are incomplete. Perhaps they are disputed. Perhaps they are forgotten. What authority remains? Who decides the ship's future? And what if different groups want different futures? The question may sound speculative, yet every civilization in human history has faced similar tensions. The difference is that civilizations on Earth possess room to maneuver. Borders shift. People migrate. New societies emerge. A generation ship offers no such escape. Its inhabitants remain together whether they wish to or not. Conflict cannot be exported. It must be resolved internally. Or it remains. This realization revealed something profound. The challenge of a generation ship is not keeping humans alive. Human beings are remarkably resilient. The challenge is keeping a human civilization alive. And civilizations are far more fragile than individuals. The distinction may be the most important clue yet, because it suggests that survival depends on something deeper than engineering, something deeper than biology, something hidden within the social fabric itself. The next stage of the investigation would focus on that invisible dimension, not machines, not ecosystems, not genetics, the human mind, and what centuries of isolation might do to it. The answer would prove even more unsettling than anyone expected. The first generations might remember the stars, not the destination star, not the distant point of light waiting centuries ahead, but the stars outside the ship, the real sky, the vastness of Earth's night, the feeling of standing beneath an open horizon. The founders of a generation ship would carry those memories with them. Their children might inherit them through stories, their grandchildren through recordings, perhaps their great-grandchildren through lessons in school. But eventually something strange would happen. The memory would begin to fade, not because anyone intended to forget, but because forgetting is what human beings do. History is filled with vanished worlds. Languages disappear. Traditions dissolve. Entire civilizations become fragments buried beneath newer ones. The people living inside a generation ship would not be immune to that process. In fact, they might be more vulnerable to it, because unlike societies on Earth, they would exist inside an environment where every cultural influence originates from within. No visitors. No immigration. No neighboring civilizations, only themselves. Generation after generation, century after century, a closed cultural ecosystem drifting through the dark. At first glance, this seems manageable. Human beings preserve knowledge all the time. Libraries exist. Archives exist. Digital records can store unimaginable quantities of information. Surely the mission could simply document everything. Problem solved. Yet history suggests otherwise, because preserving information is not the same as preserving understanding. Ancient civilizations left behind enormous quantities of writing. Many were forgotten. Some became unreadable. Others survived physically, but lost their meaning. Knowledge can disappear, even when records remain intact. Imagine finding an advanced technical manual written in a language nobody understands. The information exists, yet it is functionally lost. This is one of the hidden mysteries lurking inside every generation ship. Not whether information survives, but whether meaning survives. The distinction is enormous. A reactor maintenance guide only helps if someone can interpret it. An engineering database only matters if future generations possess the education required to use it. A generation ship could theoretically preserve every scientific document humanity has ever produced, yet still lose the ability to apply that knowledge. The possibility sounds extreme, but evidence from Earth suggests it is surprisingly realistic. History contains numerous examples of technological regression. The collapse of complex societies often leads to the loss of specialized expertise, not because knowledge vanishes instantly, because the institutions supporting that knowledge disappear. Skills require teachers. Teachers require systems. Systems require stability. Break enough links in the chain, and expertise slowly erodes, like a language no longer spoken. The implications for a generation ship are profound. Imagine a vessel operating for 500 years. The machinery is ancient. The software has evolved through countless updates. Repairs have accumulated. Modifications have been made. Components have been replaced. Every generation leaves traces. Every generation alters the system slightly. Eventually, the ship itself becomes a layered archaeological site, a living machine carrying centuries of history within its structure. Would future inhabitants truly understand everything around them, or would parts of the ship gradually become mysterious? The question is more important than it first appears. Because humans routinely interact with systems they do not fully understand, most people can drive a car without understanding engine design. Most people use computers without understanding semiconductor physics. Complex civilizations function through specialization. Individuals rely on experts. Experts rely on institutions. Generation ships face a unique problem. Those institutions must survive indefinitely. A university aboard a ship cannot simply close. A technical academy cannot permanently fail. An educational system cannot experience centuries of decline. The mission depends upon continuity, and continuity is surprisingly fragile. This realization led researchers toward a deeper concern. What if the greatest threat is not ignorance? What if it is adaptation? At first, adaptation sounds positive. Life adapts. Cultures adapt. Successful societies adapt. Adaptation is often associated with survival, yet adaptation can also alter priorities. Imagine a child born aboard a generation ship. Their entire world consists of artificial environments. Their experiences differ fundamentally from those of the founders. The founders remember Earth. The child does not. The founders view the ship as transportation. The child views it as home. This difference seems subtle, but across centuries it may become transformative. Consider an analogy. Imagine being born aboard an enormous ocean vessel. You never see land. Your parents never saw land. Their grandparents never saw land. Every story about land comes from ancient records. Eventually, a question emerges. Why should anyone believe those stories? The ship itself becomes reality. Everything else becomes abstraction. Something similar could happen aboard a generation ship. Earth may evolve into legend. The destination may evolve into myth. The mission may evolve into tradition, and traditions change. This possibility fascinated sociologists studying long-duration spaceflight because it suggested a hidden conflict embedded within the mission itself. The goals of the founders may not survive unchanged. Future generations might reinterpret them, question them, reject them, or replace them entirely. This creates an extraordinary paradox. A generation ship succeeds biologically only if new generations are born, yet each new generation increases the possibility of cultural divergence. The very process that ensures survival may gradually undermine the original mission. At first, this seems like a theoretical concern. Then history offers a sobering perspective. Many institutions founded with clear purposes eventually evolve beyond recognition. Organizations change. Religions split. Governments transform. Communities redefine themselves. The longer the timeline, the greater the divergence. Now extend that process across centuries of total isolation. The result becomes difficult to predict. Researchers began asking uncomfortable questions. Would descendants still want to reach the destination? Would they even believe the destination exists? Could they decide to remain permanently aboard the ship? Could the vessel itself become the final civilization? The answers remain uncertain, but the implications are enormous, because suddenly the generation ship is no longer merely a transportation system. It is a cultural experiment unlike anything humanity has ever attempted, and cultural experiments rarely unfold as expected. Yet an even stranger mystery was beginning to emerge. It involved something more fundamental than politics, more fundamental than education, more fundamental than culture. It involved the human mind itself, because isolation does not merely change societies. Isolation changes perception. Human beings evolved on an open planet, a world filled with changing landscapes, changing weather, changing horizons, changing opportunities. Generation ships offer none of those things. Their environments are finite, predictable, repetitive. Every corridor eventually becomes familiar. Every room eventually becomes known. Every horizon eventually reveals itself as a wall. What does that do to a population across centuries? The question remains largely unanswered. No civilization has ever lived inside such conditions. No human experiment has ever lasted long enough to provide certainty. Yet early evidence suggested the effects could be profound. And if that evidence was correct, then the greatest threat facing a generation ship might not come from failing machines or unstable ecosystems. It might emerge from the minds of the people trying to survive within them. The investigation was about to enter far more uncertain territory, because the next clues would reveal an invisible danger that no engineer could repair with tools. A danger carried within every passenger from the moment the journey begins. The danger was never supposed to be loneliness. When engineers first imagined generation ships, their attention focused on physical survival: air, water, food, energy, radiation shielding, structural integrity. The challenges seemed tangible, measurable, solvable. Psychology occupied a much smaller space in the discussion. After all, humans have always adapted to difficult environments. People survive in deserts, in polar regions, on isolated islands, inside submarines, within research stations buried beneath Antarctic ice. Surely a sufficiently advanced generation ship could accommodate the human mind. At least, that was the assumption. Then, researchers began examining what prolonged isolation actually does to people, and the findings revealed something deeply unsettling. Human beings are not designed merely to survive physically. They are designed to exist within constantly changing worlds. Our ancestors evolved amid endless variation. New landscapes, new challenges, new social interactions, new opportunities. Even the horizon itself changed. Every journey revealed something unfamiliar. Generation ships remove much of that variability. The environment becomes finite, bounded, predictable, a closed world repeating itself day after day, year after year, generation after generation. The psychological implications remain one of the least understood aspects of long-duration space travel, yet small glimpses have already emerged. Researchers studying crews in Antarctica noticed patterns. Months of isolation produced emotional strain. Conflicts intensified. Motivation fluctuated. Social relationships became unusually important. Minor disagreements occasionally expanded into major problems. Nothing catastrophic, but revealing. The environment itself influenced behavior. Submarine crews experienced similar effects. So did astronauts aboard space stations. Even though these missions lasted only months rather than generations, the lesson appeared repeatedly. Humans can tolerate isolation, but isolation changes humans, and those changes accumulate. This realization introduced a disturbing possibility. A generation ship may not merely transport a civilization, it may gradually reshape that civilization. Imagine spending your entire life inside a structure only a few kilometers wide. Every location is familiar, every route is known, every landscape is artificial. No mountains beyond the horizon, no unexplored continents, no wilderness, no genuine unknown. At first, the idea sounds manageable. People adapt to cities. People adapt to routine. Yet, there is a critical difference. Cities remain connected to larger worlds. A generation ship does not. Its boundaries are absolute. There is nowhere beyond them. The analogy is simple. A city feels like a room with doors. A generation ship feels like a room without them. The distinction may seem psychological. It is. And that is precisely why it matters. Because perception influences behavior. The awareness that escape exists changes how people experience confinement. Remove that possibility, and the emotional landscape changes dramatically. Researchers sometimes refer to this as the closed world effect, the sensation that one's entire reality exists within a finite, inescapable system. Humanity has never experienced such conditions on a civilization-wide scale. No historical comparison is perfect, yet fragments of the pattern appear throughout history. Remote islands provide clues. Small, isolated communities provide clues. Long-duration expeditions provide clues. Again and again, one theme emerges. Isolation magnifies social dynamics. Everything becomes more important. Every friendship, every rivalry, every conflict, every alliance, because alternatives are limited. The same individuals remain present year after year. The same social structures persist. The same tensions can linger for decades. A generation ship would amplify these effects enormously, which raises a troubling question. What happens when conflict becomes unavoidable? History offers a sobering answer. Conflict is not an anomaly. It is a constant feature of human societies. Disagreements occur even under favorable conditions. Political divisions emerge. Competing interests arise. Power struggles develop. Generation ships would not eliminate these tendencies. They might intensify them. Imagine a dispute over resource allocation, or educational policy, or governance, or reproductive rights, or technological priorities. The issue itself may be less important than the environment in which it occurs. On Earth, dissatisfied groups often relocate. Communities separate. Nations form. Borders shift. A generation ship offers no equivalent release valve. Every disagreement remains trapped inside the same finite space. The pressure has nowhere to go, like steam accumulating inside a sealed vessel. This realization led sociologists toward a remarkable conclusion. The success of a generation ship may depend less on engineering excellence than on social resilience, not preventing conflict, managing it, not eliminating disagreement, containing it. The distinction matters. Perfect harmony is unrealistic. Stable adaptation is not. Yet even stable adaptation may face challenges no human society has encountered before, because the ship introduces another psychological factor: scale, or rather, the absence of it. Earth provides perspective. People experience vast oceans, endless skies, distant horizons. Large environments help shape cognition in subtle ways. Generation ships compress reality. Everything becomes local. Everything becomes immediate. Everything becomes enclosed. The effect is difficult to predict. Would future generations perceive space differently? Would they develop new cultural norms? Would concepts like exploration evolve into something entirely unfamiliar? The questions remain unresolved, but they reveal how deeply the ship might influence human identity itself. And then there is perhaps the strangest possibility of all: boredom. At first, boredom seems trivial compared to radiation or ecosystem collapse. Yet boredom may represent one of the most persistent forces in human behavior. People seek novelty, challenge, discovery, purpose. Generation ships risk limiting all four. Imagine being born into a mission whose conclusion lies centuries away. No matter how hard you work, you will never see the destination. Neither will your children. Perhaps neither will your grandchildren. How do you sustain motivation under such circumstances? The founders possess purpose. They chose the mission. Future generations inherit it. That difference could prove profound. Researchers studying long-term projects often observe a phenomenon called goal dilution. The farther a reward lies in the future, the weaker its motivational power becomes. Generation ships stretch this principle to an extreme. The ultimate reward exists beyond individual lifetimes, perhaps far beyond. Would descendants remain committed, or would new priorities emerge? This question began transforming the entire investigation, because it suggested the ship's greatest challenge might not be physical survival. It might be meaning. Meaning is difficult to quantify, difficult to engineer, difficult to store in databases. Yet civilizations depend upon it. People endure hardship when hardship serves a purpose. Remove that purpose, and resilience often declines. A generation ship, therefore, requires more than life support systems. It requires narrative support systems, stories, values, institutions, beliefs. Reasons to continue, reasons to maintain the mission, reasons to preserve knowledge, reasons to cooperate. The ship must sustain not only bodies, but motivations. And motivations are notoriously fragile across long stretches of time. The deeper scientists explored this problem, the clearer it became. The generation ship was evolving into something far stranger than anyone initially imagined. It was not merely a technological challenge, not merely a biological challenge, not merely a psychological challenge. It was all of them simultaneously. An ecosystem carrying a civilization, carrying a mission, carrying a story. And if any one of those layers failed, everything else might follow. Yet just as the psychological mystery seemed overwhelming, a new discovery emerged, one that suggested an even more fundamental vulnerability hidden beneath all the others. A vulnerability not found in people, not found in ecosystems, but buried inside the machines themselves. Because the longer researchers studied generation ships, the more they realized a terrifying possibility. The ship may not need to suffer a catastrophic failure. It may simply grow old. And aging can destroy worlds just as effectively as any disaster. At first, the machines seemed dependable. Modern civilization is built upon an assumption so familiar that most people rarely notice it. Technology lasts long enough. A bridge survives for decades. A power plant survives for decades. An aircraft survives for decades. When systems wear out, replacements arrive. When components fail, supply chains respond. When expertise is needed, specialists appear. Earth is surrounded by layers of redundancy, invisible networks constantly repairing the machinery of civilization. A generation ship would possess no such luxury. Once the vessel leaves the solar system, every replacement part that will ever exist must already be on board. Every tool, every spare component, every piece of critical infrastructure. The ship carries not only its present, it carries its entire future. And that changes everything, because even the most reliable machines eventually fail. Not dramatically, not all at once, but slowly, relentlessly, through the quiet accumulation of wear. A bearing degrades, a circuit corrodes, a seal weakens, a sensor drifts out of calibration. On Earth, such failures are routine. In deep space, they become existential. The realization forced engineers to confront an uncomfortable truth. The greatest threat to a generation ship might not be sudden catastrophe. It might be maintenance. The word sounds mundane, almost boring. Yet maintenance may be the hidden foundation of civilization itself. Every city survives because countless systems are continuously repaired. Roads, pipes, electrical grids, communication networks, buildings. Remove maintenance and decline begins immediately. At first, the changes are subtle. Then they become visible. Then they become impossible to ignore. A generation ship magnifies this reality because its entire world depends upon machinery. The air is machinery. The water is machinery. The food production systems are machinery. The environmental controls are machinery. The habitat itself is machinery. Everything necessary for survival is mediated through technology, which raises a troubling question. Can any technological system truly survive for centuries? History suggests caution. Even humanity's most durable creations rarely endure unchanged. Ancient monuments survive. Ancient machines generally do not. The difference is revealing. Stone can remain passive. Machines require constant activity, and activity produces wear. Imagine owning a car expected to function continuously for 1,000 years. The idea sounds absurd. Now imagine an entire civilization depending upon that car. The challenge becomes clearer. Generation ships demand reliability on timescales almost no human technology has ever achieved. The deeper engineers examined the problem, the stranger it became, because durability alone was insufficient. A machine can survive physically, yet still become unusable. Software becomes outdated. Interfaces become obsolete. Documentation disappears. Knowledge erodes. Technology does not merely age materially, it ages culturally. This introduced a fascinating parallel. Archaeologists often discover ancient tools whose purposes remain uncertain. The objects survive. The understanding does not. Could something similar happen aboard a generation ship? Could future generations inherit systems they no longer fully comprehend? The possibility seemed unlikely at first. Then researchers considered the timeline. 500 years. 1,000 years. Perhaps longer. How much of today's technological knowledge would remain intuitive after such intervals? Consider a simple comparison. Most people alive today could not independently recreate modern semiconductor manufacturing, yet modern society depends upon semiconductors everywhere. The expertise exists because institutions preserve it, universities teach it, industries practice it, researchers expand it. A generation ship must somehow maintain that continuity indefinitely. The challenge extends beyond preserving machines. It requires preserving competence, and competence is fragile. The realization led to a disturbing analogy. A generation ship resembles a library where every book must also be rewritten continuously. If the rewriting stops, the knowledge begins to fade. The ship, therefore, requires not just hardware. It requires educational systems capable of reproducing expertise across centuries. Every engineer must train successors. Those successors must train others, generation after generation, without interruption. The process sounds simple. History suggests otherwise. Knowledge chains break surprisingly easily. Wars disrupt them. Economic collapse disrupts them. Political upheaval disrupts them. Even changing priorities can disrupt them. The challenge becomes even greater when specialized expertise is involved. A society may understand the importance of maintaining life support systems. That does not guarantee enough people will possess the skills required to do so. What happens if critical knowledge becomes concentrated in a small group? What happens if that group experiences a crisis? What happens if educational standards decline? The questions multiply rapidly, and each answer reveals additional uncertainties. This is where the investigation reached its first major false ending. For a time, many researchers believed automation solved the problem. Advanced artificial intelligence could monitor systems. Robots could perform repairs. Automated diagnostics could identify failures before they became serious. The solution appeared elegant. Human error decreases. Machine precision increases. Reliability improves. The mystery seemed closer to resolution. Then a larger question emerged. Who maintains the automation? The answer complicated everything, because automated systems are themselves technological systems. They require maintenance, updates, repairs, oversight. An artificial intelligence managing life support eventually becomes another component needing support itself. The problem had not disappeared. It had merely shifted, like moving water from one container into another. The dependency remained. This discovery transformed how scientists viewed generation ships. The objective was no longer building a machine capable of lasting centuries. The objective was building a civilization capable of maintaining machines for centuries. The distinction may sound subtle. It is not. One focuses on engineering. The other focuses on continuity. And continuity is far more difficult to guarantee. Yet hidden beneath all these concerns was another mystery. Aging does not occur only inside machinery. It occurs inside structures, inside habitats, inside materials themselves. Even a perfectly maintained vessel faces gradual deterioration. Metals fatigue. Polymers degrade. Radiation damages components at microscopic scales. Tiny flaws accumulate, year after year, century after century. The process resembles erosion. A mountain appears permanent, yet wind slowly reshapes it. A generation ship may experience a similar fate, not through dramatic destruction, through countless invisible changes unfolding across enormous spans of time. The ship itself becomes a living archaeological artifact, older, more complex, more difficult to fully understand, more dependent upon accumulated layers of repair. At some point, future inhabitants might no longer inhabit the original vessel. They may inhabit a ship rebuilt piece by piece over generations, a cosmic version of an ancient philosophical puzzle. If every component is eventually replaced, is it still the same ship? The question sounds abstract, yet aboard a generation ship, it could become practical reality. The vessel might survive precisely because it continuously transforms, which introduces an unexpected possibility. Perhaps successful generation ships are not preserved. Perhaps they evolve. Perhaps the ship arriving at its destination would barely resemble the one that departed. This idea solved certain problems, but it introduced new mysteries, because evolution does not occur only in machines. It occurs in societies. It occurs in ecosystems. And, under the right conditions, it occurs in human beings themselves. The deeper the investigation went, the harder it became to separate the ship from its inhabitants. The vessel was no longer merely carrying a civilization. It was becoming part of that civilization, and that realization pointed toward a question even stranger than technological survival. What happens when centuries of isolation begin changing humanity itself? The answer would expand the mystery far beyond engineering and into the realm of evolution. For most of human history, evolution felt distant, something that happened to ancient ancestors, something measured in fossils buried beneath stone, something unfolding across timescales too vast for individual lives to perceive. A generation ship changes that perspective, because for perhaps the first time in history, humanity could create an environment isolated enough to become its own evolutionary world. The implications are extraordinary and slightly unsettling. At first glance, it seems impossible. After all, humans evolve slowly. A voyage lasting a few centuries would barely register against the immense scale of biological evolution. Or so it appears. Yet, evolution does not always require millions of years. Sometimes it works much faster, especially when populations become isolated. History provides numerous examples. Animals reaching islands often change dramatically. Species separated by geography begin following different paths. New environments create new pressures. New pressures create new adaptations. The process is gradual, but it is relentless. A generation ship would represent one of the most extreme forms of isolation ever experienced by our species. A closed population, a closed environment, no immigration, no outside genetic exchange, a tiny branch of humanity drifting alone through interstellar darkness. The situation resembles an island, except the island itself is moving between stars. This realization introduced a fascinating question. If the voyage lasts long enough, would the descendants remain identical to the people who launched the mission? The answer depends on what we mean by identical. Genetically, changes would occur. That much is unavoidable. Every generation introduces variation. Every generation reshuffles the genetic deck. Most changes are small, most appear insignificant. Yet across centuries, accumulation becomes meaningful. The mystery is not whether change occurs. The mystery is how much. Researchers exploring long-duration isolation scenarios noticed something intriguing. Evolution is not driven solely by survival. It is also influenced by culture. Human beings create environments that alter selection pressures. Medicine changes outcomes. Technology changes outcomes. Social structures change outcomes. In many ways, humanity has become one of its own evolutionary forces. Generation ships amplify this phenomenon. Imagine a society existing inside carefully controlled artificial habitats. Certain traits may become more advantageous, others less so. New cultural norms could influence family size, education, social status, reproduction. Over time, cultural choices and biological processes begin interacting, like two rivers merging into one. The result becomes difficult to predict. This uncertainty revealed something profound. The future inhabitants of a generation ship may not merely inherit a mission, they may inherit an entirely new evolutionary trajectory. The possibility becomes even stranger when we consider the environment itself. Life on Earth evolved beneath a particular sky, a particular gravity, a particular day-night cycle, a particular biosphere. Generation ships alter all of these. Artificial lighting replaces natural sunlight. Rotating habitats create synthetic gravity. Closed ecosystems replace planetary environments. The ship becomes a world designed rather than discovered, and designed worlds can produce unexpected consequences. Scientists already know that human physiology responds dramatically to environmental conditions. Bone density changes. Muscle mass changes. Circadian rhythms change. Psychological patterns change. Even small environmental differences can influence development. Now extend those influences across generations. The outcomes become far less certain. At first, this might seem like a distant concern. Then another clue emerges, one much closer to the present. Researchers studying spaceflight have repeatedly observed how quickly the human body adapts to altered conditions. Astronauts returning from orbit often require rehabilitation. Balance shifts. Muscles weaken, bones lose density. The body responds to its environment with remarkable speed. These effects are not evolution, yet they reveal something important. Human biology is flexible, perhaps more flexible than we often realize. A generation ship would place that flexibility under continuous pressure, not for months, not for years, but for centuries. The consequences remain largely unknown, and unknowns become dangerous when they persist long enough. This is where the mystery widened beyond biology, because evolution is not limited to genes. Ideas evolve too. Languages evolve. Beliefs evolve. Institutions evolve. Cultures evolve, sometimes faster than organisms. A society isolated for 500 years would almost certainly speak differently than its founders, perhaps dramatically differently. The transformation might occur so gradually that nobody notices. One generation introduces slight changes. The next generation expands them. Eventually, the language becomes something new. History has witnessed this process repeatedly. Latin became multiple languages. Ancient dialects fractured into descendants. Speech drifts naturally through time. The same would happen aboard a generation ship. And language is only the beginning. Customs would evolve. Art would evolve. Values would evolve. The descendants might view Earth not as a homeland, but as an ancestral myth. The destination star not as a goal, but as a symbol. The mission itself could acquire meanings never imagined by its founders. This realization led sociologists toward a remarkable conclusion. A generation ship may not transport a civilization through space. It may create a new civilization entirely. At first, this sounds exciting, perhaps even inevitable. Yet it introduces a serious complication. The more a society changes, the harder it becomes to predict its future behavior. The descendants who inherit the mission may not share the assumptions of those who launched it. Why should they? Their experiences would be fundamentally different. Their world would be fundamentally different. Their reality would be fundamentally different. The ship would no longer be a temporary vehicle. It would be their universe. And that distinction may alter everything. This brings us to another hidden paradox. The success of a generation ship depends upon continuity. Yet continuity naturally produces change. The longer the voyage lasts, the greater the transformation. The greater the transformation, the less certain the original mission becomes. The ship survives by evolving, but evolution may gradually redefine what survival means. For a time, it seemed this was merely a philosophical issue. Then researchers began examining historical examples of isolated populations, and they discovered a pattern that changed everything. Isolation does not always produce stability. Sometimes it produces fragmentation. Communities diverge. Groups separate. Subcultures emerge. Different identities develop. What begins as one society can become many. A sufficiently large generation ship might experience similar dynamics. Different regions, different occupations, different traditions. Over centuries, these differences could deepen. The ship might cease being a single culture. It might become a collection of cultures sharing the same physical habitat. The implications are enormous, because now governance becomes more complex. Cooperation becomes more complex. Conflict becomes more complex. The vessel begins resembling a miniature world, complete with its own internal history. And history has a tendency to surprise us. This realization created another false sense of resolution. Perhaps diversity aboard the ship would be healthy. Perhaps multiple cultures would strengthen resilience. Perhaps adaptation itself would guarantee survival. The answer seemed encouraging. Then another question emerged. What if the greatest threat comes not from change inside the ship, but from something waiting outside it? Because while humanity was busy worrying about genetics, culture, and psychology, researchers had begun examining the environment between the stars, and what they found lurking there would reveal that interstellar space is far less empty than it appears. From a distance, interstellar space looks peaceful. The darkness between stars appears empty, silent, motionless, almost timeless. When people imagine a generation ship crossing that vast gulf, they often picture an isolated vessel gliding through a cosmic void, a lonely island floating across nothingness. But appearances can be deceptive, because space is not truly empty, and what exists within that darkness may pose dangers unlike anything humanity has ever encountered. The mystery begins with a simple misconception. Vacuum does not mean absence. Even the most barren regions of interstellar space contain matter. Not much. Far less than any laboratory vacuum on Earth. Yet across enormous distances, even tiny amounts become significant. Imagine driving through a rainstorm. A single raindrop is harmless. At highway speeds, thousands become noticeable. Now imagine traveling for centuries through a region filled with microscopic particles. The individual particles remain tiny. The accumulated impacts do not. This realization transformed how engineers viewed interstellar travel. The threat was not a single collision. The threat was countless collisions, dust grains, microscopic fragments, invisible particles scattered throughout the galaxy. At ordinary speeds, such objects pose little danger. Generation ships, however, must travel extraordinarily fast compared to anything humans routinely experience. Even 1% of light speed is roughly 3,000 kilometers per second. At those velocities, tiny particles acquire surprising energy. A grain of dust can strike with the force of an explosive projectile, and the ship may endure billions of such impacts over its lifetime. The implications are profound. Every square meter of hull becomes a target. Every exposed surface experiences gradual erosion. The process resembles cosmic sandblasting, slow, persistent, unforgiving. Engineers responded with shielding concepts, layered armor, sacrificial surfaces, protective structures designed to absorb impacts before they reached critical systems. The solutions appeared promising, yet they introduced another mystery. How long can shielding last? A system designed for decades may not survive centuries. A system designed for centuries may not survive millennia. Again, the same pattern emerged. Time magnified everything. The longer the voyage, the more cumulative effects mattered. The challenge extended beyond physical impacts. Radiation posed another invisible threat, unlike Earth. A generation ship would spend its existence beyond the protection of a planetary magnetic field, beyond the shelter of a thick atmosphere, exposed to a constant stream of energetic particles moving through the galaxy. Cosmic rays, solar particles, high-energy radiation originating from distant astrophysical events. Most pass harmlessly through empty space, yet some interact with living tissue. Some damage electronics. Some alter materials at microscopic scales. The danger is subtle. Radiation rarely announces itself dramatically. Its effects accumulate. A damaged cell here, a weakened circuit there, a tiny alteration repeated millions of times. The analogy is useful. Imagine sunlight slowly fading a photograph. No single moment reveals the change. Years later, the difference becomes obvious. Radiation operates similarly. A generation ship may spend centuries beneath an invisible storm. The question is not whether exposure occurs. The question is whether the vessel can endure it. At first, scientists believed massive shielding might solve the problem. Water layers, hydrogen-rich materials, artificial magnetic fields. Various approaches showed promise. The mystery appeared closer to resolution. Then researchers uncovered another complication. Shielding itself has limits. Adding more protection increases mass. More mass requires more energy. More energy demands larger systems. Larger systems introduce new vulnerabilities. The familiar pattern returned once again. Every solution generated additional challenges. The deeper the investigation went, the harder it became to identify any truly permanent answer. This led scientists toward a remarkable realization. Generation ships are not designed to eliminate risk. They are designed to manage risk. The distinction matters. Absolute safety may be impossible. Survival depends upon maintaining acceptable levels of danger across extraordinary spans of time. And acceptable danger becomes difficult to define when the timeline extends beyond human lifetimes. Yet perhaps the strangest threat lay elsewhere, not in radiation, not in dust, but in uncertainty itself. Interstellar space remains largely unexplored. Humanity has never sent a spacecraft beyond nearby regions of the solar system at interstellar travel speeds. Much of what we know comes from observation rather than experience, models rather than journeys, predictions rather than evidence. This creates an uncomfortable reality. The first true generation ship would enter environments humanity has never directly inhabited. The mission would become an experiment, a voyage into partially understood territory. That fact alone introduces risk. History repeatedly demonstrates that unknown environments contain surprises. Explorers crossing oceans encountered unexpected hazards. Early aviators encountered unexpected hazards. Space exploration itself has revealed unexpected hazards. Why should interstellar travel be different? The answer is that it probably isn't. Somewhere along the route, hidden phenomena may exist. Unanticipated particle concentrations, unexpected material degradation processes, rare astrophysical events, environmental factors not yet recognized. The ship would effectively become humanity's first long-term laboratory in deep interstellar space. And laboratories often produce discoveries. Not all discoveries are welcome. This realization shifted the conversation. The challenge was no longer surviving known dangers. It was surviving unknown dangers. A far more difficult problem. Because known threats can be planned for, unknown threats cannot. The distinction haunted many generation ship studies. No matter how sophisticated the design, no matter how comprehensive the preparation, uncertainty remains, and uncertainty grows with distance. A mission lasting centuries cannot rely on perfect foresight. It must rely on adaptability, the ability to respond to problems that have not yet been imagined. This brought researchers back to a familiar theme: flexibility, again and again. Successful survival seemed to require systems capable of changing. Ecosystems must adapt. Cultures must adapt. Technology must adapt. Even the ship itself may need to adapt. The vessel becomes less like a machine and more like an organism. A living system responding continuously to its environment. The comparison is revealing. Biological organisms survive because they evolve. Perhaps generation ships must do the same. The idea seemed increasingly persuasive, yet another mystery waited just beyond it, one that would force scientists to confront an uncomfortable possibility. Perhaps the ship's greatest challenge is not surviving external threats. Perhaps it is surviving success, because if the voyage continues long enough, a strange transformation begins. The descendants stop thinking like passengers. They start thinking like inhabitants, and once that shift occurs, an extraordinary question emerges. What if the people aboard no longer want to reach the destination at all? The answer would challenge the very purpose of the mission itself. The problem did not begin with rebellion, at least not in the dramatic way science fiction often imagines. No mutiny, no violent uprising, no sudden rejection of the mission. The real danger was quieter, and therefore far more plausible. It began with a simple shift in perspective. The founders of a generation ship see the vessel as transportation. The descendants may see it as home. At first, the distinction appears semantic, a matter of wording. Yet buried within those two concepts are completely different worldviews. Transportation implies movement toward a goal. Home implies permanence. Transportation exists to reach somewhere else. Home exists to be lived in. The difference may ultimately determine the fate of the entire mission. Imagine a child born 300 years into the voyage. Their parents were born aboard the ship. Their grandparents were born aboard the ship. Everyone they have ever known was born aboard the ship. The artificial habitat is not a temporary environment. It is reality itself. Earth belongs to ancient history. A destination belongs to the distant future. Neither affects daily life. What matters is the ship, the farms, the schools, the neighborhoods, the people, the world immediately around them. Human psychology naturally prioritizes the present. That tendency has deep evolutionary roots. Our ancestors survived by responding to immediate conditions, not by optimizing for outcomes centuries away. Generation ships create an unprecedented conflict between those instincts and the mission's objectives. The mission demands long-term thinking. Human beings evolved for short-term realities. The tension is unavoidable, and over enough generations, it may become transformative. Researchers studying long-term institutions noticed a recurring pattern. Goals often change as organizations age. A company founded to achieve one purpose gradually develops new priorities. A movement founded around one idea expands into something broader. The original mission remains, but its significance shifts. The same process could unfold aboard a generation ship. The founders launch toward another star. Their descendants inherit a civilization. Those are not necessarily the same project. The realization startled many researchers because it suggested a possibility rarely discussed during early generation ship studies. The mission could succeed technically while failing philosophically. The ship survives. The population survives. The ecosystem survives. The destination is reachable, yet nobody cares about reaching it anymore. At first this sounds unlikely. Then history offers a different perspective. Many societies have abandoned objectives once considered essential. Empires retreat. Colonies declare independence. Religions reinterpret doctrines. Cultures redefine priorities. The longer the timeline, the greater the divergence. A voyage lasting centuries virtually guarantees profound cultural transformation. The question is not whether change occurs. The question is whether that change preserves the original purpose. And nobody knows the answer. This uncertainty inspired one of the most fascinating debates in generation ship research. Should future generations be obligated to continue the mission? The issue is more complicated than it appears. The founders make the decision to launch. Future inhabitants do not. They inherit the consequences. They are born into a world whose fundamental trajectory was chosen long before their existence. Some philosophers argue that this creates an ethical dilemma. Do the descendants possess the right to alter the mission? Do they possess the right to abandon it? Or does the survival of the entire project depend upon preserving commitments across generations? There is no universally accepted answer, yet the debate reveals something profound. A generation ship is not merely an engineering challenge. It is an experiment in intergenerational responsibility. The scale of that experiment is unprecedented. Never before has humanity attempted to bind so many future lives to a single long-term objective. The implications extend far beyond space travel. They touch fundamental questions about civilization itself. How much do we owe the future? How much does the future owe the past? The mystery becomes even more complicated when viewed from another angle. What if abandoning the destination is not failure? What if it is adaptation? This possibility emerged as researchers considered increasingly large generation ship designs. Some concepts envisioned vessels housing tens of thousands of people. Others imagined rotating habitats approaching the scale of small cities. Such structures begin resembling independent worlds, and worlds develop identities. A sufficiently large ship might eventually become self-sustaining in every meaningful sense. Its inhabitants may no longer perceive themselves as travelers. They may perceive themselves as citizens of a permanent space-borne civilization. The destination star becomes optional. The ship itself becomes the destination. At first glance, this sounds like a solution. The mission evolves. The civilization survives. Humanity expands beyond Earth. Mystery solved. But this was another false ending, because a larger question immediately emerged. If the ship becomes a permanent civilization, what prevents it from changing course entirely? The answer is surprisingly difficult to define. Imagine a future generation deciding to stop accelerating toward the target star, or to redirect toward another destination, or to remain indefinitely between stars. From their perspective, such decisions may seem rational. From the perspective of the founders, they may seem like abandonment. Who is correct? The question remains unresolved, and perhaps it always will, because it reflects a deeper uncertainty about the nature of civilization itself. Civilizations are not static entities. They are processes, continuous negotiations between past, present, and future. Generation ships compress that negotiation into a single isolated environment. The result could be extraordinary, or unpredictable, perhaps both. The more scientists explored these scenarios, the more they realized something remarkable. The greatest threat to the mission may not come from rebellion. It may come from success. A thriving civilization develops its own interests, its own priorities, its own identity. The healthier the society becomes, the more independent it may grow. Paradoxically, perfect survival could undermine the original objective. The ship succeeds so well that it no longer needs the destination. This realization altered how many researchers framed the entire problem. The central question was no longer simply, can a generation ship survive? Instead, it became, can a generation ship survive while remaining committed to its original purpose? The distinction transformed everything, because maintaining physical systems may be easier than maintaining collective intent across centuries. And collective intent is notoriously fragile. Yet before anyone could answer that question, another mystery emerged from an unexpected direction. It concerned knowledge itself, not whether knowledge survives, not whether knowledge is taught, but whether knowledge inevitably decays. Because the longer researchers examined long-duration civilizations, the more they noticed a hidden pattern repeating throughout history. Complex knowledge is surprisingly difficult to preserve, and if that pattern applies to generation ships, then an even greater threat may be waiting beneath the surface. A threat capable of undermining every system aboard, not through destruction, through forgetting. Most civilizations believe their knowledge is permanent. The belief feels natural. A discovery is written down. A library stores it. A database preserves it. Future generations inherit it. The chain appears secure. Yet history tells a different story. Knowledge is not a monument. It is a process. And processes can break again and again. Human civilization has watched valuable knowledge fade into obscurity, not because it vanished overnight, because the systems required to sustain it gradually weakened. A language disappeared. A profession became rare. An institution collapsed. A tradition ended. The information survived somewhere, but the ability to use it did not. This distinction would become critically important aboard a generation ship, because the vessel would depend upon layers of expertise far beyond anything most historical societies required. Environmental engineering, genetics, agriculture, medicine, materials science, computing, power generation, life support management, thousands upon thousands of interconnected disciplines. The ship is not merely a machine. It is a technological ecosystem, and technological ecosystems require constant renewal. Imagine a hospital. The building itself is important. The equipment is important, but neither functions without trained professionals. Now imagine maintaining that hospital for 1,000 years without outside assistance, without external universities, without fresh specialists arriving from elsewhere. Every skill must be reproduced internally. Every generation must successfully teach the next. The challenge becomes staggering. Researchers studying cultural transmission discovered something fascinating. Human knowledge survives through repetition, not storage. Storage helps, but repetition is what keeps knowledge alive. Languages survive because people speak them. Crafts survive because people practice them. Sciences survive because people teach and apply them. Remove repetition, and decay begins. A generation ship, therefore, faces a hidden vulnerability. Certain forms of knowledge may become less frequently used, and less frequently used knowledge tends to fade. At first, the consequences seem minor. Perhaps a specialized repair technique becomes uncommon. Perhaps a rarely needed engineering procedure is no longer widely understood. Nothing catastrophic happens immediately. Then a crisis occurs. Suddenly, the forgotten knowledge becomes essential, and nobody remembers enough to apply it correctly. The danger resembles a dormant disease, invisible during normal conditions, revealed only when the system is stressed. History offers numerous examples. Ancient construction techniques lost for centuries. Navigation methods forgotten after changing technologies emerged. Manufacturing skills disappearing as industries evolved. Civilizations often assume important knowledge will persist automatically. Reality is less forgiving. The lesson carries profound implications for generation ships, because the longer the voyage, the greater the opportunity for knowledge drift. And knowledge drift may be just as dangerous as genetic drift. The analogy is surprisingly accurate. Both involve gradual loss of diversity. Both involve cumulative change. Both often remain invisible until consequences emerge. The more researchers examine the problem, the stranger it became, because knowledge is not distributed evenly. Some individuals possess more expertise than others. Some professions become highly specialized. Some systems depend upon a small number of experts. This creates what sociologists call concentration risk. The danger that critical functions become dependent on too few people. Modern civilization mitigates this through scale. Millions of engineers exist. Millions of physicians exist. Millions of technicians exist. A generation ship operates on a much smaller population base. Its margin for error shrinks dramatically. Imagine losing several generations of highly specialized expertise. The effects may not become obvious immediately. The ship continues functioning. Life continues. Then, one day, a major repair becomes necessary, and suddenly a hidden weakness reveals itself. Researchers began modeling such scenarios. The results were sobering. Small disruptions in educational continuity could produce disproportionately large consequences decades later. The effects cascaded through the system. One missing link in a knowledge chain might eventually affect entire sectors of the ship's infrastructure, like removing a single support beam from a vast structure. The collapse does not occur instantly, but stability weakens. This realization led many experts toward a controversial conclusion. Education may be more important than engineering, at least over sufficiently long timescales. The statement sounds strange. Generation ships are often imagined as technological achievements, yet technology only remains useful when people understand it. The true challenge may not be constructing advanced systems. The true challenge may be preserving the culture required to sustain those systems. This shifted attention toward institutions, schools, archives, apprenticeships, research centers, libraries. These structures suddenly appeared just as important as reactors or agricultural systems, perhaps more important, because they produce the expertise that keeps everything else alive. The ship begins to resemble a living organism once again, not because it contains biological systems, because every component depends upon every other component. Knowledge supports technology. Technology supports ecosystems. Ecosystems support people. People preserve knowledge. A circular relationship. Break any part of the loop and instability spreads. For a time, this insight appeared encouraging. The solution seemed clear. Build strong educational institutions. Preserve cultural continuity. Maintain archives. Train successors rigorously. Problem solved. Yet another complication soon emerged, perhaps the most unsettling one yet. Knowledge does not merely disappear, it evolves. Future generations may improve upon existing systems, modify them, replace them, innovate beyond them. At first glance, this sounds beneficial, and often it is. But innovation introduces unpredictability. Imagine a society aboard a generation ship, developing technologies unfamiliar to the founders. New methods, new philosophies, new scientific paradigms. The descendants become more capable in some areas, less capable in others. The balance shifts. The ship gradually transforms. The process may be healthy or dangerous, or both simultaneously. The problem is that nobody can know in advance. This realization created another false sense of resolution. Perhaps innovation would guarantee survival. Perhaps future generations would solve problems their ancestors could not. The mystery seemed to shrink. Then a larger question appeared. What if innovation itself creates new vulnerabilities? History offers countless examples. Powerful technologies often solve one problem while introducing another. Agriculture enabled civilization. It also enabled large-scale conflict. Industrialization increased prosperity. It also created environmental pressures. Every advance carries consequences. Generation ships would be no exception. Future innovations could strengthen survival. They could also alter the mission in unexpected ways. The ship's descendants may inherit tools and capabilities the founders never imagined, and those capabilities may reshape the entire trajectory of the voyage. The deeper researchers looked, the clearer it became. The future civilization aboard the ship could not be predicted. Not accurately, not completely, not even approximately beyond a certain point. The uncertainty itself became one of the central mysteries, because if the inhabitants evolve culturally, technologically, and socially across centuries, then the destination may eventually matter less than the transformation occurring during the journey. And that realization pointed toward a profound possibility. Perhaps the generation ship is not truly traveling to another star. Perhaps it is traveling toward another version of humanity. The implications of that idea would soon become impossible to ignore. For decades, Automation appeared to be the answer. Whenever a new challenge emerged, engineers returned to the same solution. Too few technicians. Automation. Too many maintenance demands. Automation. Too much complexity. Automation. The logic was compelling. Machines do not forget. Machines do not become bored. Machines do not experience political disagreements. Machines can operate continuously, patiently. Precisely. If a generation ship could automate enough of its critical functions, perhaps many of the deepest risks would simply disappear. At first glance, the idea seemed almost elegant. Artificial intelligence could monitor life support systems. Robotic maintenance units could repair damaged infrastructure. Automated agricultural systems could manage food production. Advanced diagnostics could identify problems long before they became dangerous. Human error decreases. Reliability increases. The mystery appeared to be shrinking. And for a time, many researchers believed they were approaching a genuine solution. Then they asked a simple question. What happens when the automation fails? The answer changed everything, because automation is not a replacement for complexity. It is complexity. In many cases, it increases complexity. The apparent simplicity experienced by users often conceals enormous layers of hidden machinery beneath the surface. A modern smartphone feels intuitive. Its internal systems are extraordinarily intricate. A modern aircraft can automate many tasks. Its automated systems require extensive expertise to design, maintain, and verify. The same principle applies to generation ships. Every automated function introduces new dependencies. Every dependency creates new vulnerabilities. The problem had not vanished. It had merely become harder to see. Researchers gradually realized something important. Automation does not eliminate maintenance. It transforms maintenance. Instead of repairing simple systems, future generations must maintain increasingly sophisticated ones. The challenge shifts from mechanical understanding to systems understanding, and systems understanding can be surprisingly fragile. This insight produced one of the most revealing analogies in the entire investigation. Imagine a village where every resident knows how to grow food. Now imagine replacing that knowledge with a single automated farming system. The village becomes more efficient. Food production improves. Life becomes easier. Yet something subtle has changed. The community has concentrated its survival into one system. If that system fails, the consequences become far more severe. The same dynamic may emerge aboard a generation ship. Automation increases capability, but it may also increase dependency. Dependency is not inherently dangerous until the thing being depended upon becomes unavailable. Then, dependency becomes risk. The deeper scientists explored the issue, the more paradoxical it appeared. A ship with insufficient automation may overwhelm its inhabitants. A ship with excessive automation may weaken their ability to function independently. Somewhere between those extremes lies a balance. The problem is that nobody knows exactly where. This uncertainty became even more significant when artificial intelligence entered the discussion. Modern AI systems already perform tasks that would have seemed remarkable only decades ago. Future systems may become vastly more capable. Some generation ship concepts envision artificial intelligences acting as caretakers for centuries, monitoring ecosystems, managing infrastructure, assisting education, preserving knowledge, perhaps even helping govern the civilization itself. The possibilities are extraordinary, yet they introduce another mystery. What relationship develops between a civilization and an intelligence that persists longer than any individual life? Imagine an AI operating continuously for 500 years. Every human being it first interacted with is long gone. Generations come and go. The AI remains. In some respects, it becomes the oldest inhabitant of the ship, a living archive, a witness to centuries. The implications are difficult to predict. Would future generations trust such systems, depend upon them, resent them, ignore them? The answer may vary from one century to the next, because relationships between people and technology evolve. History demonstrates this repeatedly. Tools change culture. Culture changes how tools are used. Generation ships would amplify that process dramatically. At first, many researchers viewed advanced AI as a near-perfect safeguard against knowledge loss. An artificial intelligence could preserve information indefinitely, provide instruction, maintain records, offer expertise. The solution appeared promising. Then another question emerged. Who verifies the AI? The issue sounds technical. It is actually philosophical. If future generations no longer fully understand the systems guiding them, how do they evaluate those systems? How do they know whether the information being provided remains accurate? How do they distinguish preservation from distortion? The problem resembles a historical puzzle. Ancient societies often relied upon traditions whose origins had been forgotten. The traditions persisted. The reasons sometimes did not. Could something similar happen with artificial intelligence? Could future inhabitants obey systems they no longer fully comprehend? The possibility seemed uncomfortable, yet not impossible. This realization produced another false ending. Perhaps transparency solves the problem. Ensure every system is understandable. Ensure every process is documented. Ensure every generation receives proper education. The mystery seemed manageable once again. Then reality intervened. Complex systems naturally become more complex over time. Repairs accumulate. Updates accumulate. Adaptations accumulate. Future generations modify existing systems to solve immediate problems. Those modifications create new layers. Over centuries, the structure becomes increasingly intricate. The ship evolves. Its technology evolves. Its institutions evolve. Eventually, the descendants inherit systems nobody designed intentionally, only collectively. The outcome resembles an ancient city. No single architect planned every street. No single generation built every structure. The city emerged gradually through countless decisions. Generation ships may evolve similarly. Their final form could be largely unpredictable. This insight led to a remarkable shift in thinking. Perhaps the goal is not preserving perfect understanding. Perhaps the goal is preserving adaptability. Civilizations survive not because they predict every challenge. They survive because they respond to challenges they never predicted. The distinction matters. It suggests that flexibility may be more valuable than control. Resilience more valuable than optimization. The lesson echoes throughout history. Highly specialized systems often perform brilliantly under expected conditions. Unexpected conditions reveal their weaknesses. Generation ships must endure conditions nobody can fully anticipate. Therefore, resilience becomes essential. Yet resilience itself requires resources, redundant spare capacity, backup systems, alternative pathways, and those requirements introduce another challenge. Massachusetts. Energy. Space. Every safeguard consumes something. Every layer of resilience carries a cost. The ship becomes larger, more complicated, more difficult to construct. The mystery expands once again. How much resilience is enough? No one can answer with certainty, because certainty disappears on timescales measured in centuries. The longer the voyage, the less predictable the future becomes. And that realization pointed toward a startling possibility. Perhaps no generation ship can ever be fully prepared. Perhaps survival depends not on eliminating uncertainty, but on learning how to live with it. The idea felt almost philosophical. Then scientists turned their attention back to the environment beyond the ship, and there they discovered something unsettling. Even if every internal challenge could be solved, even if the civilization remained stable, even if technology endured, the galaxy itself might still have other plans. For centuries, humanity imagined the galaxy as a vast stage. Stars were the actors, planets were the destinations. Space itself was merely the empty distance between them, a backdrop, a silent void. The assumption seemed reasonable, yet as astronomy advanced, a different picture emerged. The galaxy was not a stage, it was an environment. And environments have histories, they have dangers, they have hidden processes unfolding across immense scales. A generation ship would not simply travel through space, it would travel through the Milky Way itself. And the Milky Way is far from static. At first, the dangers appear manageable. A ship spends most of its voyage crossing relatively empty interstellar regions. Stars remain distant. Collisions remain unlikely. The galaxy seems peaceful. Then researchers begin examining longer timescales, centuries, millennia, perhaps longer. And suddenly, the galaxy starts moving. Stars orbit the galactic center. Clouds of gas drift. Radiation environments change. The cosmic landscape evolves continuously. What appears fixed from a human perspective becomes dynamic when viewed across generations. The analogy is simple. Imagine standing in a forest. For a few minutes, everything seems still. Return after centuries, and the forest is unrecognizable. Trees have fallen. New growth has emerged. Entire ecosystems have shifted. The galaxy behaves similarly, slowly, quietly, relentlessly. This realization introduced an unexpected complication. A generation ship's journey is not occurring against a fixed backdrop. The backdrop itself is moving. The destination star moves. Neighboring stars move. The solar system moves. The ship must navigate a changing celestial environment. Fortunately, astrophysics allows such motions to be predicted with remarkable accuracy over many timescales. Yet prediction is not the same as certainty, especially when voyages stretch beyond ordinary human planning horizons. This uncertainty led researchers toward another question. Could rare cosmic events threaten long-duration missions? The answer was uncomfortable. Possibly. Most of the time, the galaxy is relatively calm. Most stars live uneventful lives. Most regions of space remain stable for millions of years. But most is not the same as all. Some events are rare precisely because they unfold across enormous volumes and timescales. Supernovae, gamma-ray bursts, stellar flares. Exotic astrophysical phenomena. A generation ship traveling for centuries slightly increases its exposure to such possibilities. Not dramatically, but enough to matter. The challenge lies in probability. Rare events become less rare when enough time passes. A 1 in a million occurrence seems irrelevant during a weekend. It feels different across a 1,000-year voyage. The mystery was no longer about immediate threats. It was about cumulative exposure to uncertainty. And uncertainty has a habit of growing with time. Yet even these cosmic hazards were not what truly captured scientists' attention. The more profound discovery involved communication, or rather, the gradual disappearance of it. When a generation ship first launches, contact with Earth remains possible. Messages travel back and forth. Data flows. Updates arrive. The civilization aboard the vessel remains connected to its origin, at least initially. Then distance begins doing what distance always does. It separates. A ship traveling toward another star slowly moves beyond convenient communication. Signals require years to arrive, then decades. Eventually, perhaps longer. Conversations become impossible. Only correspondence remains. And correspondence unfolds at the pace of astronomy. Imagine asking a question and waiting 30 years for a reply, then waiting another 30 years after responding. Meaningful interaction collapses. The ship becomes increasingly independent. This transition may be one of the most psychologically significant moments in the entire voyage. At first, Earth remains real, present, reachable through communication. Then gradually it becomes remote, almost historical. Eventually, Earth transforms into something resembling an ancestor rather than a partner. The civilization aboard the ship must solve its own problems, interpret its own future, create its own path, because help can no longer arrive in time. This realization produced one of the most profound perspective shifts in generation ship research. The vessel is not merely carrying people away from Earth, it is carrying them away from human civilization itself. The distinction matters enormously. For most of history, even remote communities remained connected to larger networks. Trade routes, migration, communication, influence. Generation ships eventually lose all of these. The isolation becomes absolute, perhaps for the first time since humanity emerged as a species. And that isolation introduces a remarkable possibility. The descendants aboard the ship may cease thinking of themselves as an extension of Earth. They may begin thinking of themselves as something separate, a new branch of humanity, a civilization with its own identity, its own history, its own destiny. At first, this sounds like a cultural issue. Then the implications become much larger, because separate civilizations tend to diverge. Different priorities, different values, different technological paths, different interpretations of reality itself. The longer separation persists, the greater the divergence becomes. This observation brought researchers to a startling conclusion. The first successful generation ship may not merely create a new settlement, It may create a new civilization, one whose development unfolds independently of Earth, one whose future cannot be predicted from Earth's perspective, one whose descendants may eventually feel more connected to the ship than to the planet that launched it. The implications are enormous, and they reveal another hidden layer of the mystery. Perhaps the greatest challenge is not reaching another star. Perhaps it is surviving the transition from one civilization into another. This realization marked the end of the investigation's second act. The clues were beginning to converge. Ecosystems drift. Knowledge decays. Technology ages. Cultures evolve. Isolation transforms identity. The pieces no longer looked separate. They appeared interconnected, like fragments of a much larger pattern. For a time, it seemed the mystery was finally becoming clear. A generation ship survives by adapting. The answer appeared almost obvious. Then researchers encountered evidence that complicated everything once again. Because adaptation itself has limits, and beyond those limits waits a question so large it changes the entire investigation. Not whether a generation ship can survive, but whether any civilization can remain unchanged while surviving long enough to cross the stars. What scientists discovered next would force them to reconsider the meaning of survival itself. At first, survival seemed easy to define. A generation ship launches. It remains operational. Its inhabitants stay alive. Eventually, it reaches another star. Mission accomplished. The definition appears straightforward. Yet, the deeper scientists investigated, the more elusive the concept became. Because survival is not a binary condition. It exists on a spectrum. A forest survives after a fire, yet it is not the same forest. A civilization survives a war, yet it is not the same civilization. A species survives an environmental shift, yet it is not exactly the same species. Change and survival are often inseparable. This realization transformed the generation ship mystery. The question was no longer whether the ship could endure. The question became, what exactly survives? The answer proved surprisingly difficult. Imagine a vessel that reaches its destination after 1,000 years. The original crew is long gone. Their children are gone. Their grandchildren are gone. Dozens of generations have lived and died within its walls. Languages have evolved. Institutions have evolved. Technology has evolved. Culture has evolved. The people who finally arrive may have little in common with those who departed. Biologically human, certainly. Historically connected, undoubtedly. But culturally, psychologically, philosophically, the continuity becomes less obvious. This observation led researchers toward one of the most profound discoveries in the entire field. Generation ships may not transport civilizations. They may transform civilizations. The distinction is subtle, yet it changes everything. Transportation implies preservation. Transformation implies emergence. The destination receives not a copy of the departing society, but its descendant, a new entity shaped by centuries of adaptation. At first, this seemed like an abstract philosophical concern. Then history provided a powerful analogy. Consider ancient Rome. The people living within the Roman Empire would have recognized their civilization. The descendants living centuries later often would not. Languages shifted. Religions changed. Political structures evolved. The continuity remained real. Yet the transformation remained undeniable. Now imagine that process unfolding inside a closed world drifting between stars. The implications become enormous. The generation ship itself becomes a cradle of historical evolution, a moving civilization producing its own future. This realization created a remarkable perspective shift. The voyage may be more important than the destination. For centuries, discussions focused on arrival. Arrival at another star. Arrival at another planet. Arrival at another home. Yet most of the story unfolds before arrival ever occurs. Entire civilizations may rise and fall during the journey. Entire cultural eras may emerge. Entire social revolutions may occur. The ship becomes a historical stage, a world generating its own narrative. The destination becomes merely the final chapter, and perhaps not even the most important one. This insight led to another question. If transformation is inevitable, should the mission attempt to resist it? Some researchers argued yes, Preserve founding values. Preserve original objectives. Preserve continuity wherever possible. Others argued the opposite. Adaptation is survival. Attempts to freeze culture may weaken resilience. The debate remains unresolved because both perspectives contain truth. Too much change risks losing the mission. Too little change risks losing adaptability. The ship must navigate between those extremes, like a vessel steering through a narrow channel. This balancing act revealed another hidden layer of the mystery. Successful survival may require accepting transformation without surrendering identity. An extraordinarily difficult challenge, perhaps the most difficult challenge of all. Then, researchers encountered an even stranger possibility, one rarely discussed during early studies. The possibility that the ship itself becomes alive in a cultural sense, not biologically alive, something more subtle. Civilizations often develop symbolic relationships with their environments. Rivers become sacred, mountains become sacred, cities become sacred, places acquire meaning beyond their practical functions. Generation ships may experience something similar. Future inhabitants might view the vessel not as technology, but as heritage, not merely infrastructure, but identity. The ship becomes home, history, culture, memory, perhaps even mythology. The walls themselves become part of civilization's story. The analogy is simple. Ancient cathedrals were originally buildings. Over time, they became symbols. Generation ships may undergo the same transformation. The habitat ceases being a machine. It becomes a civilization's shared inheritance. This shift could strengthen survival. People protect what they value. They preserve what they revere. Yet it could also create new complications, because symbolic meaning evolves. Interpretations differ. Narratives compete. The ship's significance may change from one era to another. Again, the familiar pattern appears. Every solution introduces fresh uncertainty, and uncertainty expands with time. For a moment, it seemed the mystery had reached a satisfying conclusion. Survival requires adaptation. Adaptation produces transformation. Transformation creates a new civilization. The answer felt elegant, perhaps even complete. Then another discovery shattered that sense of closure. A discovery emerging not from sociology, not from history, not from psychology, but from mathematics. The numbers revealed something startling. The longer the voyage lasts, the more difficult prediction becomes. Not linearly, exponentially. Tiny uncertainties compound. Small deviations accumulate. Minor changes amplify. The process resembles weather forecasting. Tomorrow's forecast is usually reliable. Next month's forecast becomes uncertain. A prediction centuries into the future approaches impossibility. Generation ships face the same challenge. No model can perfectly anticipate 1,000 years of cultural evolution. No simulation can fully predict ecological drift. No calculation can capture every technological innovation. The future civilization becomes increasingly unknowable, and that unknowability changes the nature of the mission itself. The founders launch a ship. What arrives may be impossible for them to imagine. This realization may be the most profound clue yet, because it suggests that generation ships are not simply mechanisms for transporting humanity across space. They are mechanisms for creating futures beyond present understanding. The ship becomes a bridge into unknown history, not merely unknown geography. And once that idea enters the story, the entire mystery expands. The challenge is no longer reaching another star. The challenge is releasing control over what humanity becomes during the attempt. That realization would soon force scientists to confront an even larger question. Not whether the ship survives, not whether civilization survives, but whether humanity itself remains recognizable after enough time has passed. The answer would push the investigation into territory far stranger than anyone expected. The assumption had always been simple. A generation ship carries humans to another star. The people who arrive may be descendants of the people who left, but they remain fundamentally the same species, the same humanity, the same story, the same civilization extended across distance. At least, that was the expectation. Then researchers began examining what happens when enough time accumulates. Not decades, not centuries, millennia. Suddenly, the assumptions became less secure, because time is not merely a measure of duration. Time is an engine of transformation. Everything exposed to it changes. Languages change. Cultures change. Technologies change. Ideas change. Life itself changes. 1,000 years feels immense to individual human beings. Yet, from an evolutionary perspective, it is only a beginning. The mystery was not whether change would occur. The mystery was how many different forms that change might take. At first, the most obvious possibility involved biology. A population isolated for long enough inevitably develops its own characteristics. Most would be subtle. Many would go unnoticed. But over extraordinary spans of time, accumulation matters. The descendants of a generation ship may adapt to environments unlike anything experienced on Earth. Artificial gravity, artificial ecosystems, artificial cycles of day and night, artificial architecture shaping daily life. The ship itself becomes an evolutionary landscape, and landscapes leave traces. Yet biology was only one layer of the story. Cultural evolution moves far faster, sometimes dramatically faster. A civilization can reinvent itself within a few generations. History demonstrates this repeatedly. The world of medieval Europe differed profoundly from the Roman world that preceded it. Modern civilization differs profoundly from the medieval world, and all of those transformations occurred while populations remained connected to larger networks of exchange and communication. Generation ships remove those connections. The isolation may accelerate divergence in unexpected ways. Imagine a civilization existing for 1,000 years within a structure only a few kilometers wide. Every aspect of life revolves around systems designed for survival. Recycling becomes sacred. Efficiency becomes cultural. Maintenance becomes tradition. Waste becomes taboo. The environment itself shapes values, not through force, through necessity. Future generations may develop worldviews that seem unfamiliar to their ancestors, perfectly rational within the ship, perfectly strange to outsiders. The realization fascinated anthropologists because it suggested that generation ships may produce entirely novel forms of human culture, not copies of Earth, not extensions of Earth, something new. A civilization born from the conditions of deep space itself. This idea seemed increasingly plausible. Then another possibility emerged, one even stranger. What if future generations choose deliberate transformation? Humanity is already beginning to alter itself. Gene editing, biotechnology, neural interfaces, artificial intelligence. The trend is unmistakable. Future civilizations may possess tools capable of reshaping biology intentionally. Generation ships amplify the incentives. Imagine a population adapting itself for life aboard the vessel. Improved resistance to radiation, enhanced metabolic efficiency, modified sleep cycles, altered sensory systems, traits optimized for closed environments. The concept sounds speculative today, yet over sufficiently long timescales, such possibilities become difficult to dismiss. The descendants might not simply evolve, they might redesign themselves. And if that occurs, another question immediately follows. At what point does adaptation become transformation? The answer is deeply uncertain. History provides no precedent. Humanity has never maintained a civilization in total isolation while simultaneously possessing advanced technological capabilities. The combination is unprecedented, which means predictions become increasingly fragile. Every answer generates new mysteries. The pattern had become familiar by now, yet this particular mystery felt larger because it touched something fundamental: identity. What does it mean to remain human? The question appears philosophical. Generation ships may eventually make it practical. If future generations think differently, live differently, perceive reality differently, and perhaps even modify themselves biologically, where exactly does continuity reside? In genetics, in culture, in memory, in shared history. No single answer satisfies completely. The deeper researchers explored the issue, the more elusive it became. Then an extraordinary realization emerged. Perhaps continuity has never required sameness. Humanity today differs enormously from humanity thousands of years ago, yet we still recognize a connection. The chain remains unbroken. The story continues. Generation ships may simply extend that process, not preserving humanity unchanged, allowing humanity to continue changing. This insight seemed to resolve the mystery. Perhaps transformation is not a threat. Perhaps transformation is the mission. For a moment, the conclusion felt convincing. Then another complication appeared, one far larger than culture, far larger than biology, far larger than civilization. The universe itself entered the story, because while researchers debated the future of humanity, physicists were confronting a different question, a question about permanence. And permanence, it turns out, may be an illusion. The realization begins with entropy, the tendency of systems to drift toward disorder. Everything experiences it. Machines wear down. Structures decay. Information degrades. Energy disperses. The process is universal, relentless, unavoidable. Generation ships do not escape entropy. They merely fight it. Every repair is a battle against it. Every act of maintenance is a battle against it. Every educational institution preserving knowledge is a battle against it. The ship survives because its inhabitants continuously push back against decay. Yet entropy never disappears. It waits. Patiently. This perspective changed how some scientists viewed the entire project. The generation ship was no longer simply a vessel crossing space. It was a civilization resisting entropy. A tiny island of order moving through a universe where disorder steadily grows. The analogy is beautiful and unsettling because it suggests survival is not a destination. It is a process, a continuous act of renewal. The moment renewal stops, decline begins. This insight created a profound shift in the investigation. Success may not mean arriving. Success may mean continuing to adapt, continuing to learn, continuing to preserve enough order to remain alive. The destination becomes secondary. The process becomes primary. At first, this felt almost reassuring. Then researchers followed the logic further and discovered something extraordinary. If survival depends upon endless renewal, then perhaps no civilization ever truly solves the problem. Not on Earth, not among the stars, not anywhere. Every society exists within the same struggle. Different scales, different environments, the same underlying challenge. The implication was enormous. Generation ships were not revealing a unique problem. They were revealing the hidden condition of civilization itself. The voyage simply magnified it, made it visible. And once that realization emerged, the mystery grew larger than the ship. Larger than humanity, larger even than the galaxy. The investigation was no longer asking how long a generation ship could survive. It was beginning to ask how long any civilization can survive. And that question would lead toward one of the most unsettling discoveries of all. For a brief moment, it seemed the mystery had finally yielded an answer. Build a sufficiently large ship, create resilient ecosystems, preserve knowledge, maintain cultural continuity, encourage adaptation, manage technology wisely. If all those conditions are met, survival appears possible. Perhaps even indefinitely. The conclusion felt satisfying, elegant, almost inevitable. Then mathematics intervened, and the answer became far less certain, because every complex system shares a hidden characteristic. It accumulates risk, not necessarily catastrophic risk, not necessarily visible risk, but risk nonetheless. Tiny probabilities, small uncertainties, rare failures, individually insignificant, collectively transformative. Imagine flipping a coin. One flip tells you very little. 1,000 flips reveal patterns. 1,000,000 flips reveal inevitabilities. Generation ships operate on similar principles. The longer the timeline, the greater the opportunity for unlikely events to occur. This observation transformed the investigation. The challenge was no longer surviving known dangers. The challenge was surviving all possible dangers. and that is a profoundly different problem. Consider a simple example. Suppose a critical system has a reliability of 99.99%, an extraordinary achievement by modern standards. For a short mission, that reliability appears almost perfect. Extend the timeline to centuries and the picture changes. Failures become increasingly probable, not because the system is poorly designed, because probability accumulates. The mathematics is merciless. Time turns rare events into expected events. This realization forced researchers to rethink everything. Generation ships could not be designed around preventing failures. Failures were inevitable. The goal had to be surviving failures. The distinction matters enormously. A civilization expecting perfection is fragile. A civilization expecting disruption becomes resilient. History repeatedly confirms this lesson. The societies that endure are not those avoiding every crisis. They are those recovering from crises. Generation ships therefore require a fundamentally different philosophy. Not stability, adaptable stability. Not permanence, renewal. The ship becomes less like a monument and more like a living ecosystem, continuously repairing itself, continuously reinventing itself, continuously responding to uncertainty. At first glance, this insight appears encouraging. The mystery seems manageable once more. Then researchers expanded the timeline. Not centuries, thousands of years. The numbers became startling. Even highly improbable events begin appearing. Unexpected ecosystem shifts, rare technological failures, unusual social crises, statistical anomalies. The longer the voyage, the more opportunities reality has to surprise you. The ship enters a domain where prediction becomes increasingly unreliable. This led to a remarkable conclusion. There may be no such thing as a truly permanent generation ship, only generation ships surviving one challenge after another. The difference is subtle, yet profound. Permanence implies certainty. Survival implies adaptation. One assumes control, the other assumes uncertainty, and uncertainty appears everywhere. A forgotten repair procedure, a rare disease, an unforeseen ecological interaction, a political transformation, an unexpected technological dependency. Any one of these may be manageable. The challenge lies in their accumulation. The ship must endure not one problem, but thousands. Not one century, but many. The scale becomes difficult to comprehend. Researchers sometimes use an analogy from engineering. Imagine balancing a pencil on its tip. For a moment, it remains upright. Given enough time, gravity eventually wins. Now imagine continuously adjusting the pencil, correcting every drift, compensating for every wobble. The balancing act can continue far longer. Generation ships resemble this second scenario. Survival depends upon endless correction, endless vigilance, endless adaptation. The moment adjustment ceases, decline begins. This realization created another false ending. Perhaps artificial intelligence solves the problem. Perhaps automation provides endless vigilance. Perhaps advanced technologies eliminate human limitations. Again, the answer appeared within reach. Again, the answer created a larger question. Because technology itself exists within the same framework of uncertainty, every solution introduces new dependencies. Every dependency introduces new risks. The cycle never ends. The deeper scientists explored the issue, the clearer a pattern emerged. There is no final solution, only ongoing management. The insight felt strangely familiar because civilization on Earth functions exactly the same way. Cities survive through maintenance. Institutions survive through renewal. Knowledge survives through education. Nothing remains stable automatically. Everything requires effort. Generation ships merely expose this reality more clearly. The voyage strips away the illusion of permanence. What remains is process. Continuous process. Then researchers encountered an even more surprising possibility. What if enormous generation ships evolve into something resembling ecosystems rather than vehicles? Some proposed designs became astonishingly large, rotating habitats kilometers in diameter, populations numbering tens of thousands, complex internal economies, multiple cultural groups, generational institutions. At such scales, the distinction between ship and world begins to disappear. The vessel ceases being transportation infrastructure. It becomes habitat, civilization. Environment, a self-contained branch of humanity. This idea seemed revolutionary, and perhaps it was, because large-scale habitats possess advantages. Greater redundancy, greater diversity, greater resilience. Failures affecting one region need not threaten the whole. Different communities can pursue different strategies. Adaptation becomes easier. For a moment, researchers believed they had found the answer. Build bigger. Build more complex. Build more resilient. The mystery appeared solved once again. Then a familiar complication emerged. Large systems create new vulnerabilities. Political fragmentation, resource competition, institutional complexity, coordination challenges. The same forces that strengthen resilience can also weaken cohesion. The solution and the problem grow together, like two vines climbing the same wall. This pattern had become impossible to ignore. Every attempt to eliminate uncertainty merely changes its form. The ship survives not by escaping uncertainty, but by learning to coexist with it. The realization was profound and deeply unsettling because it suggested something larger. Perhaps uncertainty is not a flaw in the mission. Perhaps uncertainty is the mission. The voyage becomes an experiment whose outcome cannot be fully predicted. A civilization launching itself into unknown history, not simply unknown space. The destination remains distant. Yet another destination is already appearing, a future humanity no one can completely imagine. And as researchers followed this line of thought, they uncovered an implication even more extraordinary. The greatest challenge facing a generation ship may not be survival at all. It may be deciding what survival actually means. That question would soon force the investigation beyond engineering, beyond sociology, and beyond biology, into the very nature of civilization itself. For most of the investigation, survival seemed like the ultimate goal. Keep the ship functioning, keep the population alive, reach the destination. Everything else appeared secondary. Then a strange possibility emerged. What if survival and purpose are not the same thing? At first, the distinction feels philosophical, almost abstract. Yet it may be the most important question a generation ship will ever face. Because civilizations do not survive merely through biology. They survive through meaning. Human beings can endure extraordinary hardship when they believe that hardship serves a purpose. History is filled with examples. Explorers crossing oceans, settlers crossing continents, scientists dedicating entire lives to discoveries they may never witness completed. Meaning transforms sacrifice into investment. Without meaning, sacrifice begins to resemble suffering. Generation ships stretch this principle to an unprecedented extreme. The founders choose the mission. Future generations inherit it. And inheritance changes everything. Imagine being born 800 years into the voyage. You did not launch the ship. You did not select the destination. You did not make the promises. Yet your entire existence is shaped by decisions made centuries before your birth. The question becomes unavoidable. Why continue? At first, the answer seems obvious. Because the mission matters. Because arrival matters. Because the future matters. Yet every civilization in history has eventually reinterpreted the meaning of its institutions. No purpose remains completely unchanged forever. Generation ships are unlikely to be different. Researchers began exploring this issue through thought experiments. The results were fascinating. Suppose the descendants discover a way to live comfortably and indefinitely aboard the vessel. No resource crisis, no technological collapse, no existential emergency. Life becomes stable, prosperous, meaningful. In such a scenario, why leave? The question sounds almost heretical, yet it follows naturally from the logic of success. A thriving civilization may no longer perceive the destination as necessary. The ship itself may already provide everything its inhabitants value. This realization challenged one of the deepest assumptions in generation ship design, that reaching another star remains the ultimate objective. Perhaps it does for the founders, perhaps it does not for their descendants. The distinction could become decisive because objectives are not preserved automatically. They require continuous renewal, continuous justification, continuous relevance, and relevance changes across time. The further scientists pushed this idea, the more intriguing it became. What if arrival is not the end point? What if the ship becomes a permanent civilization moving between stars? A wandering world, a nomadic branch of humanity, never settling, never stopping, continuing indefinitely. At first glance, the concept seems radical. Then history offers an unexpected analogy. For much of human existence, mobility was normal. Hunter-gatherers moved across landscapes. Nomadic cultures crossed continents. Movement itself became identity. Perhaps a sufficiently advanced spacefaring civilization develops similar characteristics. Not attached to planets, not attached to stars, attached to journeys. The generation ship transforms from transportation into lifestyle. The destination becomes optional. The voyage becomes permanent. This possibility fascinated some researchers and deeply unsettled others because it altered the meaning of success. The mission was no longer a bridge between two worlds. It became a world unto itself. For a time, the idea seemed liberating. Then another complication emerged, one of the largest yet. Civilizations need stories, shared narratives, common purposes. These narratives bind individuals together across generations. Without them, cohesion weakens. The challenge for a generation ship is that its story must remain meaningful for centuries, perhaps millennia. History suggests this is extraordinarily difficult. Stories evolve, interpretations diverge, priorities shift. A narrative that inspires one generation may feel irrelevant to another. The mission therefore faces a hidden vulnerability: narrative decay. The gradual erosion of collective purpose, not through catastrophe, through reinterpretation. The process is subtle, almost invisible. A slight change here, a different emphasis there, generation after generation. Eventually the story becomes something new. This realization led sociologists toward a remarkable conclusion. The most important system aboard a generation ship may not be technological. It may be cultural. A civilization capable of renewing meaning may survive challenges that destroy more advanced societies. A civilization that loses meaning may struggle despite abundant resources. The lesson echoes throughout history. Empires have collapsed with full granaries. Nations have fractured despite wealth. Material prosperity alone does not guarantee continuity. The same principle may apply in deep space. The ship requires food, water, energy, technology, but it also requires reasons to cooperate. Reasons to maintain institutions, reasons to preserve knowledge, reasons to invest in futures. No individual will personally experience. The challenge is immense. Yet another discovery complicated matters further, because meaning itself evolves. A society that successfully renews purpose may not preserve the original purpose. Instead, it may create new ones. The ship's descendants could develop goals completely different from those imagined by the founders. New scientific ambitions, new cultural ambitions, new philosophical ambitions. The mission expands, diversifies, transforms. Again, the familiar pattern appears. Adaptation ensures survival. Adaptation also produces change. The two are inseparable. At this point, the investigation reached a remarkable threshold. The original mystery was beginning to dissolve, not because it had been solved, because it had become something larger. The question was no longer, how long can a generation ship survive? The question was becoming, what kind of civilization emerges when survival itself becomes the central organizing principle? The distinction matters. One focuses on technology, the other focuses on humanity, and humanity is far less predictable. The deeper researchers examined long-duration societies, the more they encountered the same conclusion. Future generations may not merely inhabit the ship, they may redefine what it means to be human, not biologically alone, culturally, psychologically, philosophically. The ship becomes a laboratory for alternative futures. Each century introduces new possibilities. Each generation creates new branches of history. The outcome cannot be known in advance. And perhaps that uncertainty is unavoidable. Because the future has always remained partially hidden from the present, generation ships simply make that reality impossible to ignore. Yet just as the mystery seemed to reach its largest scale, another revelation appeared, one that expanded the story beyond civilization entirely, beyond humanity, beyond the ship, into the fundamental structure of the universe itself. Because even the most resilient civilization remains subject to a force older than stars, a force that has shaped every system since the beginning of time, and confronting that force would change everything. The force was never hidden. It surrounds us constantly, shapes every process, touches every object, guides the fate of stars, galaxies, civilizations, and living beings alike. Yet most people rarely think about it, because it operates slowly, quietly, patiently. Its name is entropy, and entropy may be the ultimate antagonist in the story of every generation ship. At first glance, entropy sounds like a technical concept, a topic for physicists, a mathematical description of disorder. But beneath the equations lies something much more profound. Entropy is change moving in one direction. The tendency for organized systems to become less organized unless energy is continuously invested to maintain them. Ice melts, metal corrodes, memories fade. Structures age. Information degrades. Everything drifts. Not because something has gone wrong, because this is how the universe behaves. Generation ships are remarkable precisely because they attempt to resist this drift. Every system aboard exists to preserve order. Air recycling preserves atmospheric stability. Agriculture preserves biological stability. Education preserves informational stability. Governance preserves social stability. The entire vessel becomes an island of organized complexity, surrounded by cosmic darkness. And maintaining that island requires endless effort. This realization transformed the investigation. The ship was no longer merely crossing interstellar space. It was engaged in a continuous struggle against entropy, a struggle shared by every civilization that has ever existed. The difference is that deep space makes the struggle visible. On Earth, vast natural systems absorb many consequences. Atmospheres regenerate. Ecosystems recover. Planetary processes provide support. Generation ships must create their own support structures. Every act of renewal becomes intentional. Every act of preservation becomes conscious. The challenge is relentless, and that challenge reveals something extraordinary. Civilization itself may be understood as a method for resisting entropy. Libraries resist informational entropy. Medicine resists biological entropy. Engineering resists structural entropy. Culture resists historical entropy. The pattern appears everywhere. Humanity survives by continuously pushing back against decay. Generation ships simply extend that process across greater distances and longer timescales. At first, this insight seemed almost comforting. After all, civilization has been resisting entropy for thousands of years. Why should a generation ship be different? Then researchers examined the numbers, and the numbers were humbling. Every repair consumes resources. Every institution consumes resources. Every act of maintenance consumes resources. The ship must constantly transform energy into order. Without energy, the struggle ends. This requirement introduces a hidden dependency. The vessel's survival ultimately rests upon its ability to sustain renewal indefinitely. And indefinite processes are difficult to guarantee. The challenge resembles keeping a fire burning through centuries. One missed generation, one critical failure, one prolonged disruption. The flame weakens, perhaps permanently. The analogy is not perfect, yet it captures something essential. Civilization is not a structure. It is a process requiring continuous participation. The moment participation ceases, entropy advances. History demonstrates this repeatedly. Ancient cities decline, road networks deteriorate, institutions collapse, knowledge disappears. Not because destruction arrives dramatically, because maintenance gradually stops. Generation ships face the same reality, only magnified. This realization led scientists toward a profound conclusion. The ship's greatest achievement may not be reaching another star. It may be maintaining continuity long enough to try. Continuity becomes the true miracle, not speed, not distance, persistence. For a time, it seemed this insight brought the mystery into focus. The answer appeared almost elegant. A generation ship survives for as long as it successfully resists entropy. Simple. Then another question emerged, perhaps the largest question yet. Can entropy ever be defeated permanently? The answer appears to be no, not according to current physics. Entropy can be delayed, managed, redirected, locally reduced, but never eliminated. The universe itself evolves under its influence. Stars exhaust their fuel. Galaxies change. Cosmic structures transform. Nothing remains perfectly ordered forever. The implication is staggering. Even the most successful generation ship exists within a larger process it cannot escape. Eventually, every system faces limits. At first, this sounds discouraging. Then researchers notice something fascinating. Life has never required permanence. Life requires continuity. There is a difference. A tree does not live forever. Forests endure through succession. Individuals die. Species persist. Civilizations transform. History continues. The ship may operate according to the same principle. Its survival does not depend upon remaining unchanged. It depends upon preserving enough continuity to carry the story forward. The distinction is subtle, yet it may be the most important discovery in the entire investigation, because it shifts the focus away from permanence toward renewal, toward adaptation, toward resilience. These qualities appear repeatedly across every successful system. Biological systems, ecological systems, social systems, technological systems. The pattern is unmistakable. The systems that endure are not those avoiding change. They are those incorporating change. Generation ships may ultimately survive by embracing transformation rather than resisting it. This realization created a remarkable perspective shift. The ship becomes less like a fortress, more like a living organism, less like a machine, more like a process. A dynamic civilization continually rebuilding itself across generations. The image feels strangely organic, and perhaps that is appropriate, because life itself operates through continuous renewal. Generation ships may simply extend life strategy into interstellar space. Yet even this revelation did not fully solve the mystery, because another layer remained hidden beneath it. A layer involving scale. The ship struggles against entropy. Civilizations struggle against entropy. Stars struggle against entropy. Galaxies struggle against entropy. The same pattern appears everywhere. The investigation was no longer about a spacecraft. It was becoming a story about complexity itself. And complexity exists throughout the cosmos. The realization was breathtaking. A generation ship may be a miniature version of something much larger, a small reflection of processes shaping the universe itself. If that was true, then the final chapters of the mystery would no longer concern engineering or civilization alone. They would concern reality itself, and what reality may be trying to teach us through the fragile survival of a tiny world drifting between the stars. By this point, the generation ship scarcely resembled the simple spacecraft that began our investigation. What started as an engineering problem had expanded into something much larger. A question about ecosystems, a question about culture, a question about memory, a question about entropy, and now, unexpectedly, a question about the universe itself. Because the deeper scientists looked, the more they noticed a strange pattern. The challenges facing a generation ship were not unique. They appeared everywhere, different scales, different forms, the same underlying struggle. A generation ship must preserve order against disorder. So does a civilization. So does a planet. So does a star. Even galaxies participate in similar processes. The realization was subtle. Then it became impossible to ignore. Perhaps the ship is not an exception. Perhaps it is a miniature version of reality. Consider a star. At first glance, it appears permanent, a brilliant beacon burning steadily across cosmic time. Yet stars survive only through continuous balance. Gravity pulls inward. Fusion pushes outward. The tension creates stability. Remove either force and the star changes dramatically. Its apparent permanence is actually an ongoing process, a dynamic equilibrium. Generation ships operate similarly. Technology balances decay. Education balances forgetting. Culture balances fragmentation. Maintenance balances entropy. The stability is real. Yet, it is never static. The same principle appears again and again throughout nature. Forests, coral reefs, civilizations, galaxies. Complex systems survive through continual adjustment. The discovery felt profound, almost philosophical. Then astrophysics introduced another layer, because the universe itself may be far less stable than it appears. Human beings often imagine reality as a fixed stage upon which events unfold. Modern cosmology tells a different story. The universe evolves. Space expands. Stars form. Stars die. Galaxies collide. Cosmic structures transform continuously. The largest scales of existence are not static. They are historical. The universe has a past. It has a future. It has a trajectory. This perspective changes how we view the generation ship. The vessel is no longer merely moving through space. It is moving through a changing cosmos, a participant in an unfolding story billions of years old. And that story contains mysteries of its own. At first, this realization seems disconnected from the practical challenges of survival. Then another analogy emerges. Imagine a small boat crossing an ocean. The crew focuses on food, water, navigation, and weather. Yet all those concerns exist within a larger reality, the ocean itself. The boat survives only because it remains compatible with its environment. Generation ships face the same condition. Their survival depends upon remaining compatible with the universe they inhabit. The universe provides energy, matter, physical laws, constraints, possibilities. Everything occurs within that framework. This insight produced one of the most fascinating perspective shifts in the entire investigation. Perhaps the real challenge is not building a ship capable of surviving deep space. Perhaps the real challenge is building a civilization capable of remaining compatible with reality itself. The distinction sounds abstract, yet history suggests it is profoundly practical. Civilizations survive when they align themselves with underlying conditions. They struggle when they ignore them. The same principle applies to ecosystems. The same principle applies to technologies. The same principle may apply to interstellar societies. For a time, this seemed to provide a satisfying conclusion. The ship survives by understanding and adapting to reality. The answer felt elegant. Then another question appeared, one even larger. What if reality itself imposes limits no civilization can overcome? The possibility has haunted cosmologists for decades, not because it is immediate, because it is fundamental. Every known source of usable energy is finite. Stars eventually exhaust their fuel. Matter itself evolves. Cosmic environments change. The universe is dynamic. The implication is extraordinary. No civilization exists outside cosmic history. Not Earth, not future colonies, not generation ships. Everything participates in larger processes. The realization was humbling and strangely beautiful, because it suggested that humanity's greatest achievements remain connected to something far older than humanity itself. A generation ship crossing interstellar space is not escaping the universe. It is expressing the universe, a pocket of organized complexity carried forward by physical laws that also created stars and galaxies. The ship becomes part of a much larger narrative, one stretching back to the beginning of cosmic history. This perspective transformed the meaning of survival. Survival was no longer about permanence. It was about participation in an ongoing process of renewal and transformation. Life emerged from cosmic evolution. Civilization emerged from life. Generation ships may emerge from civilization. Each layer builds upon the previous one. Each layer carries the story forward. The continuity is astonishing, yet continuity does not guarantee certainty. And certainty remained elusive. The deeper scientists explored long-term futures, the more they encountered unknowns, unknown technologies, unknown cultural transformations, unknown discoveries, unknown challenges. The future refused to become predictable. This realization produced one final false ending. Perhaps advanced science eventually removes uncertainty. Perhaps sufficiently intelligent civilizations solve every major problem. Perhaps the mystery disappears. The idea was tempting. Then history intervened. Every major scientific breakthrough has revealed new questions. Not fewer questions, new layers of complexity, new layers of uncertainty. The horizon moves. The unknown expands. Knowledge grows. Mystery grows with it. Generation ships may follow the same pattern. The more capable they become, the more possibilities emerge. The more possibilities emerge, the more unpredictable the future becomes. The mystery survives. Not because humanity fails, because reality is larger than any single answer. And that realization brought the investigation to its final threshold. The ship had become more than a spacecraft, more than a civilization, more than a technological achievement. It had become a mirror, a way of examining humanity's relationship with time, uncertainty, and existence itself. Only two questions remained. How long could such a vessel truly survive? And what might that answer reveal about us? After following the clues through ecosystems, civilizations, psychology, evolution, technology, and cosmology, we finally arrive at the question that seems so simple at the beginning. How long could a generation ship survive in deep space? By now, the answer feels very different, because we have learned something unexpected. There is no single number, no definitive century, no universal expiration date. The mystery cannot be solved with a calculation alone. At first, this conclusion feels unsatisfying. Science often seeks precise answers, exact measurements, reliable predictions. Yet some questions resist simplification. Generation ships belong to that category. Not because they are impossible to analyze, because too many layers interact simultaneously. A ship might fail due to ecological instability, or technological decay, or cultural fragmentation, or political conflict, or unforeseen cosmic hazards, or none of these. A civilization might adapt successfully to every challenge. The outcome depends upon countless variables unfolding across immense spans of time. The deeper researchers investigated, the more they realized that survival resembles probability rather than certainty. A generation ship is not crossing a finish line. It is navigating a landscape of possibilities. Every century introduces new branches, new decisions, new risks, new opportunities. The vessel's future becomes a tree of potential histories. Some branches end early, others continue. A few may extend far beyond anything we can presently imagine. This perspective changed how many scientists approached the problem. Instead of asking whether a generation ship can survive, they began asking under what conditions survival becomes likely. The distinction matters, because likelihood can be improved, resilience can be increased, adaptability can be strengthened. The future remains uncertain, but uncertainty is not the same thing as impossibility. The evidence suggests something remarkable. Humanity already possesses many of the traits required for success. We adapt. We learn. We cooperate. We preserve knowledge. We create institutions. We recover from crises. History is filled with examples. Civilizations have endured wars, pandemics, famines, migrations, and environmental upheavals, not perfectly, not without loss. Yet continuity persisted. Generation ships may simply represent those same strengths operating under more extreme conditions. This realization introduces a fascinating perspective. Perhaps the ship is not the fragile element. Perhaps humanity is more resilient than we assume. Again and again throughout history, people have solved problems their ancestors considered impossible. Flight, electricity, space travel, global communication. Each achievement once appeared unreachable. Then it became normal. The same pattern may apply to generation ships. Future civilizations could develop capabilities we cannot yet imagine. New forms of governance, new educational systems, new ecological technologies, new methods of preserving continuity. The unknown is not merely a source of danger, it is also a source of possibility. For a time, this thought feels reassuring. Then the larger perspective returns, because possibility operates in both directions. The future contains opportunities. It also contains surprises, and surprises remain unavoidable. No model can capture every variable. No prediction can anticipate every discovery. No civilization can eliminate uncertainty entirely. This may be the deepest lesson hidden within the generation ship mystery. The goal is not control. The goal is navigation. Humanity does not survive by mastering the future. Humanity survives by responding to futures it never expected. The distinction appears repeatedly throughout history. The societies that endure are not those predicting every challenge. They are those adapting when predictions fail. Generation ships amplify this principle dramatically. Their inhabitants inherit uncertainty as a permanent condition, and perhaps that is not a weakness. Perhaps it is a defining characteristic of intelligent life itself. The realization feels almost paradoxical. The more we understand, the more uncertainty becomes visible. The more capable we become, the more possibilities emerge. Knowledge expands, so does mystery. Astronomy provides a perfect example. Every telescope has revealed wonders. Every telescope has also revealed new questions. The universe continually proves larger than expected. Generation ships may teach a similar lesson. The deeper we explore survival, the more survival reveals itself as an ongoing process rather than a final achievement. This insight brings us close to the heart of the investigation, because the generation ship was never only about reaching another star. It was about confronting time. Most human projects unfold within individual lifetimes. Generation ships operate beyond them. The mission requires thinking across centuries, perhaps millennia. The scale changes everything. Short-term assumptions break down. Immediate rewards become less important. Continuity becomes central. The ship forces humanity to view itself through a longer lens, and through that lens, civilization begins to resemble something organic, not a collection of individuals, a living process extending across generations. Each generation inherits the work of those before it. Each generation modifies it. Each generation passes something forward. The pattern feels familiar because it already surrounds us. Civilization itself is a generation ship. Not literally, historically. None of us created the world we inherited. None of us will personally witness its ultimate destination. Yet we participate in the journey. We maintain systems, preserve knowledge, create institutions, transmit stories, invest in futures beyond our own lifetimes. The parallels are striking. Perhaps that is why generation ships fascinate us so deeply. They reveal something hidden in plain sight. The voyage between stars resembles the voyage humanity has always been undertaking. Across time, across generations, across history. The spacecraft simply makes the process visible. The realization is beautiful and slightly haunting, because it suggests that the ultimate challenge is not technological. It is ethical, cultural, civilizational. Can we care about futures we will never see? Can we preserve meaning across centuries? Can we remain committed to projects larger than ourselves? Generation ships ask these questions explicitly. Civilization asks them quietly every day, and the answers remain unfinished. Just like the voyage itself. Only one final mystery remains, and it may be the largest of all. In the beginning, we believed we were investigating a spacecraft, a vessel designed to cross the darkness between stars, a machine carrying human beings toward a distant destination. The question seems straightforward. How long could it survive? Now, at the end of the investigation, the question feels almost unrecognizable, because the ship was never merely a ship. It was a lens. A way of looking at humanity from a perspective so vast that familiar assumptions begin to dissolve. Along the journey, one illusion after another fell away. We thought survival was primarily an engineering problem. Then ecosystems complicated the story. We thought ecosystems were the central challenge. Then culture complicated the story. We thought culture was the central challenge. Then psychology complicated the story. We thought psychology was the central challenge. Then evolution, entropy, and uncertainty expanded the mystery even further. Each answer opened a larger question. Each discovery revealed another layer hidden beneath it. And perhaps that pattern is the most important clue of all, because it mirrors the history of science itself. Humanity rarely discovers final answers. More often, humanity discovers deeper questions. The horizon retreats. The unknown expands. The mystery survives. Generation ships embody that process perfectly. At first glance, they appear to be solutions. A solution to distance. A solution to interstellar travel. A solution to humanity's confinement within a single planetary system. Yet the deeper we look, the more generation ships reveal themselves as questions. Questions about civilization. Questions about memory. Questions about identity. Questions about time. Questions about what it means to continue existing across centuries. Perhaps that is why the concept remains so compelling. Not because it guarantees humanity's future, because it forces us to think about the future differently. Most people experience history as something behind them. Generation ships reverse that perspective. History moves ahead. The most important chapters have not yet been written. The most important decisions have not yet been made. The people who ultimately determine the mission's fate may not even exist yet. That realization is both humbling and extraordinary. It reminds us that civilization is larger than any individual life, larger than any generation, perhaps even larger than any single world. The ship becomes a symbol of continuity, a fragile continuity, yet continuity nonetheless. A chain stretching across centuries, maintained by people who inherit responsibilities from strangers long dead, and pass those responsibilities to strangers not yet born. The pattern sounds familiar because it already defines civilization. Every library, every university, every scientific institution, every cultural tradition, all are attempts to move something valuable through time. Generation ships simply make the process impossible to ignore. They transform history into architecture, responsibility into engineering, hope into infrastructure. The result is one of the most ambitious ideas humanity has ever imagined. Not because of the distance involved, because of the trust involved. Trust that future generations will continue the work. Trust that knowledge can survive. Trust that meaning can survive. Trust that civilization itself can survive. Whether that trust is justified remains uncertain. And uncertainty has accompanied us throughout this entire investigation. It appeared in the ecosystems, in the technology, in the psychology, in the culture, in the future itself. Again and again, certainty slipped away. At first, that seemed frustrating. Then it began to look meaningful, because uncertainty may not be evidence of failure. It may be evidence of reality. Reality is larger than our models, larger than our predictions, larger than our plans. Generation ships confront that truth directly. No blueprint can anticipate every challenge. No founder can control every outcome. No civilization can fully predict what it will become after centuries of change. The future remains partially hidden, always. Perhaps that hidden future is not an obstacle. Perhaps it is the point. After all, every generation inherits a world it did not create. Every generation faces mysteries it did not choose. Every generation contributes something before passing the story onward. The voyage continues, not because anyone possesses perfect knowledge, because imperfect knowledge is enough. Enough to learn, enough to adapt, enough to continue. This realization transforms the original question. How long could a generation ship survive? Maybe centuries, maybe millennia, maybe far longer than we can presently imagine. Or perhaps not. Perhaps unforeseen challenges eventually prove overwhelming. Perhaps some voyages fail. Perhaps many do. The universe offers no guarantees. Yet the deeper lesson may not depend on the outcome, because even asking the question reveals something extraordinary about our species. Humanity is one of the few known forms of life capable of imagining futures beyond individual lifetimes, capable of planning across centuries, capable of building projects whose completion will never be witnessed by their creators. Generation ships represent that ability taken to its ultimate extreme, a civilization attempting to send not merely people, but history itself across the stars. And that ambition tells us something important, not about the ship, about us. We often describe humanity as a species of explorers. Perhaps that is true. But exploration may not be our defining characteristic. Perhaps continuity is the desire to carry knowledge forward, to carry stories forward, to carry life forward across oceans, across continents, across generations, and someday, perhaps, across the galaxy. If that day comes, the first generation ship may appear small against the backdrop of cosmic history, a tiny world drifting through enormous darkness, a fragile island surrounded by interstellar night. Yet within that island would exist something astonishing, a civilization refusing to stop, a chain of memory stretching across centuries, a declaration that even in a universe of vast distances and relentless entropy, life can continue writing its story. And perhaps that is the real mystery we uncovered. Not whether a generation ship can survive, but why humanity keeps trying to survive at all. Maybe the answer lies somewhere deep within every civilization that has ever existed. A quiet impulse, a persistent echo, a refusal to let the story end. And if that is true, then the first generation ship may not simply be traveling toward another star. It may be carrying one of the oldest forces in the universe itself. The desire for complexity to continue. The desire for life to continue. The desire for meaning to continue. Perhaps. And perhaps that is enough. And before you leave tonight, I'd love to hear your thoughts. If humanity ever builds a true generation ship, would you volunteer to board it, knowing you would never see the destination? And that the mission would belong to people not yet born? Let me know down in the comments. I always enjoy reading your ideas, theories, and questions. And if you enjoy these journeys into the deeper mysteries of space, time, and our place in the universe, consider subscribing and joining us for future investigations. There are still countless unanswered questions waiting beyond the horizon, hidden among distant stars. Buried within the history of the cosmos, and perhaps even within reality itself. Until next time, thank you for watching, and wherever you are in the universe tonight, keep looking up.